Alright, so like, I want to start off the stream by proving that I'm a magical bitch. Men can be witches too. I'm pretty sure men can be prego also. Anyways, I'm gonna magically get the highest bit set in any number, any 64-bit number, using only this bit mask, or like 6-bit masks. Why 6-bit masks? Because the 64-bit number, if you go over to the handy dandy calculator, it's not working. Calculator, right? I should just set to 0. I'm gonna type in the number 63. That's the highest bit set in a 63-bit number. I mean 64-bit number. So I'm typing 64. It's in 10 for decimal. I'm gonna convert it to hexadecimal, or it doesn't matter. Okay, see how it's 1 bit over? That's because it's 64. You got a -1. Because it's only 63 bit position. There we go. 6 bits. 1, 2, 3, 4, 5, 6. That's why I only need 6-bit masks. One, 2, 3, 4, 5, 6. And this is like the source number. It's only 6 masks. 6 masks. I'm gonna get the sign bit of any number, any 64-bit number. I'm gonna directly translate to the position of the highest set bit into an indiced number with straight up brute force logic. Okay, so I'm gonna take this here, make a copy of it. Here's the last step of this file. I'm gonna ask Chatbot to give me like 5 random 64-bit numbers with only 1 bit set. The first part of the trick isn't that magical, it's not that exciting, and I didn't come up with that part. I just figured out this part. I asked Chatbot. Chatbot said nobody else has done this or figured this out, so I'm claiming this method. It's mine. I've said it like way long ago in a couple of videos, multiple times. Alright, so, wait, why am I on this computer? I'm gonna ask Chatbot to give me like 5 random numbers with 1 bit set. And I'll find the highest bit set, the bit position. So whatever the highest bit set is, I'm gonna get the indice of it without any loops, without any math. Just pure logic. Because I'm a magical bitch. I'm pretty sure men can be bitches too. If not, then I'm not. I don't know, whatever. Going by a label is such a stupid thing. Okay, so I'm gonna ship out for 5 random numbers with 1 bit set, 64-bit, like size D, whatever. Give me 5 random 64-bit numbers. With 1-bit set. And output the numbers as binary. Binary padded to 64 bits. Or padded to 64 digits. And chatbot says, chatbot makes the worst random numbers. Okay, this isn't that bad. And chatbot's wrong. Already it's wrong. This is bit 0, this is bit 1, this is bit 2. Oh no, it's right, never mind. Yeah, no, it was totally wrong earlier. So now I'm like double questioning everything. Alright, so I'm gonna paste the numbers here. I guess this is the result. Assuming this is right, I wouldn't take it for granted. I wouldn't like read this number at all and believe it. But it might be right. Last stream, chatbot's totally wrong. It was wrong like several times in a row. Alright, so paste the numbers and I use magic to like get the highest bit set to position, which is like, as you can see, it's a number position. The 1 is set. Right here. Or it's set over here. And I'm going to get that bit position with only masking. I don't even need a loop or math or anything. Just pure logic. I mean magic. It's magic. Alright, so I'm going to duplicate this 5 times because there's 5 numbers. Two, 3, 4, 5. I'll paste it, all 5 of them. Two, 3, 4, 5. Alright, so I'm now going to compute the highest bit set with pure magic. So I have to scan for where the bit's at. But really, you would mask with an operation. I'm not going to explain the whole thing. I've done that before. I'm just going over the magic part. Alright, so that's bit. So I'm going to extract it right here. I'm going to put the value right here. And I'll check it to see if it's correct. So that's first one. Now next one, just pure magic. And now I'm showing my magic trick. People can take it, but I don't care. I have so many tricks. This is like one of the couple I'm gonna share. The rest are more clever, so I'm keeping them with me. Copy Copy, paste. Alright, one more left. Last one. Now, assuming the chatbot was correct in the values I gave earlier, I'm going to take these 5 numbers. I'm going to paste them in a chatbot and ask it to convert these numbers from binary to decimal. A prefix was 0b. Because that's what chatbot checks for something, I don't know. Alright, so I'm going to pass this in as chatbot to convert these to decimal. And I'll compare it to what chatbot said it gave me. It's freaking magic. Alright, so my chatbot. Convert this list of binary numbers. Of binary format numbers. To decimal. And here's what chatbot says. So I'm going to compare that to what chatbot told me its bits were shifted off, whatever. Okay, so I'm going to scroll up. Bum, 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 bum. How does it not match up? Dang it, it didn't copy. Okay, so looks like got an issue here. So these ones are wrong. But who's wrong? Your chatbot. Chatbot can't be wrong. Okay, one of these. End up with 4 bits. Alright, so 315. So this one's right for sure. This is the 3rd bit. This is 115. 16. 15. That's 15. It's 15. Okay, so I think that's 15. So chatbot is wrong. X. Alright, 44. I see 36. My magic says 36. So 1, 2, 3. 3. Let's just do this. Wait, why is this not even showing up? I probably gotta restart this computer. Okay, here it is. So I say 36, chatbot says 44. This is 31 because halfway. 32, 33, 34, 35, 36. I said 36. So chatbot is wrong again. Wow, look at that. I'm smarter than chatbot. Whoop-de-doo. Alright, then 41. I say 26. That's a big difference. How did I get 41 out of this? Anyways, I'm gonna go down to that one, second last. I think it's 21. This is 16, halfway. 17, 18, 19, 20. 27. 26. Okay, count again. So there's extra spaces. $26. Chatbot's wrong again. How can chatbot do that? How could chatbot be so wrong? That's what it originally told me. Chatbot said, here's these numbers. This is where the bit's set, and these, where the bit is set in these numbers. I need some water. In these numbers. Right from the chatbot. It's broken. So this one's like really obvious. Second to last. This says bit 41 here. So I'm going to make 10 bits, copy paste it 4 times to get to 40, then add 1. So 1, 1, 2, 3, 4, 5. Copy. That's 10. That's 20. That's 30. That's 40. This is 41. Let's go like this. Like, this is totally serious. How is chatbot this bad? How can magic be smarter than chatbot? For fuck's sake. See, literally, I'm not cheating. It's 10, 10, 10, and then 1 at the end. Alright, so this is 41. I'm gonna paste it here. Does this look like 41 to you? Chatbot said bit 41 is set. How far away is this from 41? Chatbot's supposed to take people's jobs? Are you kidding me? People think chatbot is intelligent? Are you kidding me? And people don't believe in magic. Okay, I'm done with this magic trick. I'm gonna paste this inside of a online calculator. I'll do this number here. So 41. We'll check I did actually convert this correctly. It did convert the binary to decimal correctly, but it did not get the bit position right. It's just so wrong. It's not even funny how bad it is. What is funny is that Chrome has never met the standard, any of them, the JavaScript ECMA 262. And it's funny because I'm going to meet the standard. And I have a whole lot of tricks up my sleeve. And my JavaScript engine is way, way, way faster than Chrome. I'm going to be adding video games to my JavaScript engine and extending it to 64-bit. But 64-bit isn't part of the standard, so I'm going to wait on that. I got to meet the standard first, then I'll adjust it. Because I want to show first that it's possible to meet a standard. And so my engine will actually be compliant if needed. Because it doesn't hurt to meet a standard and then make up your own stuff, like add game loops, frame loops, FPS loops, physics loops, input loops. Adding all that after you meet the standard though, that makes a lot of sense. But not even meeting the standard in the first place and then calling yourself meeting the standard, it's like saying you're a car without wheels but still saying you're a car. So I'm going to go from page 1 to page 816. The engine is already done. I just have to finish converting it to 64-bit. So I have already sprinkled my magic code, magic dust all over the program, the engine. It's really fast. But I get a chance to sprinkle some more magic on it, make it even faster. So I'm gonna go through the whole thing, all 800 pages. I'm gonna timestamp every single section into the whole entire standard from top to bottom. And on top of that, I'm gonna add video game support because that's where the money's at. So I'm gonna add video games. And who doesn't want to go to a website where they can take the video game and simply export the whole game right into the window? Imagine how cool that would be. Imagine how much money that would save. I mean, you make a 3D game, and now you want to make a website. So you gotta hire web designers. You gotta hire people to flatten images. Now you can make a 3D scene in Unity or Unreal and export the whole game, or however much of the game you want, because you don't want to put the whole game on the internet. That could be possible too. But you could export it right into the browser. Like the Doom website. This is Foom. I missed it. So this website is what? It's kind of flat. Imagine how cool it'd be if Bethesda could simply export the game engine. One of the scenes have all this stuff moving around in the background with a real JavaScript engine that's actually performant. So I'm adding 64-bit support to my version of standard because the standard is 32-bit. So I'm gonna make sure my engine actually works for video games. So wouldn't that be cool? Wouldn't that save money? You already have a video game. and then you gotta make it flat. And you gotta make like images, you gotta put text on it, and you get this. It's so flat. There's no reason why JavaScript is so terrible. Well, there is. It's because I guess there's not enough magical bitches programming. But there are a lot of dumbass idiots programming. I don't know, I won't get into it. I'd hate to like offend elites. I mean, what could be worse than that? Like, to face reality and have it stare back at them. And then to like compete with something that they can't possibly beat. That'd be pretty funny. I don't know, anyways. I'm gonna get done with the JavaScript engine. But first I have to finish up the shader program on the GPU. Because I gotta like distort the screen when I'm doing magical stuff with code. I like saying magical stuff because that's really funny. It's like, what the fuck does that even mean? I don't know. I'm just saying words, man. Come on, man. Anyways. I don't know, the magic show's over for now. I gotta like... have to get this spinning quad. And a quad is two triangles. Because in GPU land, triangles are squares and squares are triangles. Because everything is triangle. It's triangle land. It'll drive you crazy. If the triangles don't drive you crazy, it'll be the globals, the structs, the call depth. I mean, like, all this screams gonna drive you crazy. This is ridiculous. So I have the spinning quad, and it's scaled to 16 by 9 ratio or something. I also have the display capture. Well, I had the display capture. Let's try this one. Man. Oh, I was gonna say edit this. Okay, hold on. I got it. I got this, just like I'm gonna get from page 1 to page 816 and do something that's never been done. Okay, now it should work. Okay, so it captures the desktop or whatever. And it puts it to like a command buffer, but there's like another buffer, and there's like a reference to the buffer, and there's like a structure that holds all these like parameters for the references for the other things. And it's pretty much never ending. I'm trying to get one stupid video. Here we go. Okay, so I got the desktop here. It's being captured. And I got the quad. At first I only had a triangle. So I don't know, this is called progress. I had a triangle. Then I got the desktop capture. The desktop capture. And then this has to go on the quad that I just got. So I got the quad now. What's this? And I have to put the desktop capture onto the quad. And the quad's already scaled to like, or ratioed to like 16:9 or whatever. And I have to put the desktop into the quad. And the quad needs to go into the quad needs to go into this. This is a crappy PNG. Like, I have to take the video or download it from YouTube and grab it or whatever. And then this is gonna go inside of this. This is as big as it gets. So I don't know. Like the center here. This looks really crappy. I gotta put this inside of here. And I'm gonna pixelate this display, whatever. So I need this. Like I literally simply need this. So I'm working on code. You can't see it. So that way when I'm working on magical stuff, it's distorted and pixelated. So like, I don't want to just take this guy's border, so I'm using my own border. I have to like remake it. I just threw it together. And I have to like, I don't know. It's really simple though. It's only taken 8 days. I don't know anything about the GPU, but I've learned quite a bit. I really don't care though. I just want to be done at this point. So I need to get the desktop inside of this frame here. I got this spinning quad, gotta put the desktop on it. I mean, it's gonna work at some point. I'm getting there. I'm literally so close. It's not yet, but really close. So close. Alright, I gotta figure this out. It is so hot. I need winter to go away. I need winter to come back. It's like the heat to leave. Alright, so I'm gonna text to speech, the standard. I gotta find some music, turn on a fan. It's so hot. I need winter to come back. AC, it's not the same. It's still like the air is still hot. Like you cool the air with AC, but it's still freaking hot. Dry.
Objects or symbols, initially a new empty list.
Is this working? I think it's working.
To be kept alive until the end of the current job, once the values of, and have been observed by any agent in the agent.
Alright, I'm gonna get this done. This stream is gonna be done, running, and then I can actually get to like
between ECMA's
programming and meet the standard, whatever.
atomic operations are always log-free. In practice, if an atomic
I literally just need this program to like pixelate the screen.
free, there is no upper bound on
It's such a simple thing. I couldn't find a program on Linux. I did, but it's like
is log-free.
it ate up too much memory resources.
On atomic access,
This is a 15, 16-year-old computer,
they still be
a first Gen i7.
operate memory accesses. See read share.
I'm using this computer because
International
I'm setting up my engine for the bottom. Like this is one potato computer.
not corresponds to
I think it's like 14th Gen Intel.
notation. Commas.
So those are 14 potato computers.
Operation agent signifier takes
So I'm setting up for one potato computer,
the following steps when called.
and then I'll add support for all the extended SIMD instructions and stuff
The abstract
for the 14 potato computers.
performs the following steps.
So I want to make sure I hit the baseline and everything up from there.
Surrounding agent. Return AR agent clusters. Note in some environments it may not be reasonable.
Because Chrome, Microsoft, they all say, oh, we like to make compatible programs. It's like, I'm going to show you what the word compatible means.
Operating on shared memory. Every
And I'll show that by taking your profit
have the same value for the field in their
and competing because my product is superior
respective agent records. Similarly for the field, all agents with
and it's magical.
their respective agent records. An embedded
I don't know what that means. I'm going to start saying it all the time.
resume forward progress. An agent without the agent's knowledge or cooperation. If the embedding does so, it must not.
Okay, so system settings.
Agents in the cluster are deactivated indefinitely. Note 1 programs within different agents may share memory by unspecified means. At a minimum,
About the system.
this can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2 the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B,
See, I don't know.
agent C,
Super old, first Gen i7.
and B could share some memory with C.
If it runs on this one potato, it's going to run on a 14 potato.
62.
Definitely. That's why I'm going to add support for SAMD and stuff. Instruction set.
To avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example,
I have a whole lot of stuff to do,
lifetime independent of documents and any windows will
and I'm struggling over the freaking video card because it's a bunch of crap.
worker were to be deactivated while the dedicated worker holds a
I hate this.
document is pushed
It's ridiculous.
and the shared worker then tries to acquire the lock. Then the shared worker will be blocked until
I gotta find some music to get this done.
if ever. Meanwhile, other workers.
This is a stream. It's gonna be done.
The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend weight collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, wait list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5e. Examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agent's whimper. Agent resource accounting indicates that the agent is runaway. Note 6. All agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7. An agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. Point 9. Forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024-163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. 0.10 Processing model of weak ref and finalization registry targets 9.10. 1 Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which do not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous ECMA script execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMA script execution. Because hosts may assemble longer, synchronous ECMA script execution runs, the specific time defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMA script implementations include garbage collector implementations which run in the background, including when ECMA script is idle. Letting the host enviro then schedule cleanup finalization registry allows it to resume ECMA script execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols, S a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref der for the weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sec CST writes, note, eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed by other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024. There exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 Liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, any CMA script implementation may perform the following steps atomically. For each element of R, bl0ws S, do, a for each weak ref such that ref is value, do, I set ref to empty, B for each finalization registry FG such that FG contains a record cell such that cell is value, do, I set cell to empty, 2. Optionally, perform, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, F, G. See for each weak map such that map contains a record R such that R value, do, I set R, 2. Set R to empty, D for each weak set such that set contains value, do, I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024-165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dev variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited. Because calling capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, finalization registry, the host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion, cleanup finalization registry, finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, schedules cleanup job to be performed at some future time. If possible, it must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMA script implementations are expected to call clear-kept objects when a synchronous sequence of ECMA script executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12. Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13. Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry has an internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. Choose any such cell. Be remove cell from finalization registry. See perform. Host call job callback, undefined, cell, return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument v, any CMA script language value, and returns a boolean. It returns true if and only if v is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If v is an object, return true. If v is a symbol and key for symbol, v is undefined, return true, return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resource. S in implementations. 0. Ordinary and exotic objects behaviors. 0.1. Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot. or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMA script language value, and ESC is a property descript to record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O1, 0, 1, 1. 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O1, 0, 1, 2, V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary set prototype of O, V1, 0, 1, 2, 1 ordinary set prototype of O, V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, V. Current is true, return true. Let extensible be O if extensible is false, return false. Let bev, let done be false. Repeat. World un is false if P is null. Then I set done to true. Be else if same value, P, O, is true. Then I return false. See else. I if P is not the ordinary object internal method defined in 1, 0, 1, 1. Set done to true. 2. Else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for int 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. O1, 0, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return O1, 0, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. O1, 0, 1, 4. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O. P1, 0, 1, 5. 1 ordinary get own property. O. P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else, A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D, 0, 1, 6, P, desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define known property. O, P, desk 1, 0, 1, 6. 1 ordinary define known property. O, P, desk. The abstract operation ordinary define known property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be. O, P, let extensible be. Is extensible. O, return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor undefined, and returns a boolean. It performs the following steps when called. Return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1, 0, 1, 6, 3, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P R O P E R T Y, capital D E S C R I O P, extensible, desk, current. The abstract operation, capital V A L I D A T E, capital A N D, capital A P P L Y, capital P R O P E R T Y, capital D E S C R I, takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property currents while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called: assert, is property key, P, is true if current is undefined. Then, A if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desk, is true. Then, I create an own accessor property named P of object O whose, and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose, and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value, otherwise you return true. Assert, current is a fully populated property descriptor. If desk does not have any fields, return true. If current is false, then 70. ECMA International 2024. ABC. If desk has a field and desk is true, return false. If desk has a field and desk is not current, return false. If is generic descriptor, desk, is false and is accessor descriptor, desk, is not is access, SOR descriptor, current, return false. D if is accessor descriptor, current, is true, then I if desk has a current. 2. If desk has a current, else if current is false, then I if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then if is data descriptor, current, is true and is accessor descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor, current, is true and is data descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. See else. I for each field of desk, set the corresponding attribute of the property named P of object O to the value of the field 7. Return true. 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7. 1. Ordinary has property O, P. The abstract operation ordinary has property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, P. If his own is not undefined, return true. Let parent be O. If parent is not null, then a return parent. P5. Return false. 0, 1, 8. The property key and receiver an ECMA script language value and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Return. Ordinary get O, P. Receiver ECMA International 2024 171 10 1 8 1. Ordinary get O, P. Receiver. The abstract operation ordinary get takes arguments O, an object, P, a property key, and receiver an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then a let parent be O, B. If parent is null, return undefined. C. Return parent. If is data descriptor, desk, is true, return desk. Assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return. Call, getter, receiver, 0, 1, 9. The return. Ordinary set O, P, V. Receiver 1, 0, 1, 9. 1. Ordinary set O, P, V. Receiver. The abstract operation ordinary set takes arguments O, an object, P, a property key, V, an ECMA script language value, and receiver, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be O, P. Return. Ordinary set with own descriptor O, P, V. Receiver, own desk, 0, 1, 9. 2. Ordinary set with own descriptor O, P, V. Receiver, own desk. The abstract operation ordinary set with own descriptor takes arguments O, an object, P, a property key, V, an ECMA script language value, receiver, an ECMA script language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be. O, b if parent is not null, then I return parent. I set own desk to the property descriptor, undefined, true, true, true if is data descriptor, own desk, is true, then 72, ECMA International 2024, ABCD, E, if own desk is false, return false. If receiver is not an object, return false. Let existing descriptor be. Receiver, P, if existing descriptor is not undefined, then I if is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor, V, if, return. Receiver, P, value desk, else, I assert, receiver does not currently have a property P. 2. Return. Create data property, receiver, P, V, assert, is accessor descriptor, own desk, is true. Let setter be own desk. If setter is undefined, return false. Perform. Call, setter, receiver, V, return true, 0, 1, 1, 0, P, the internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return, ordinary delete, O, P10, 1, 1, 0, 1 ordinary delete, O, P, the abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be. O, P, if desk is undefined, return true. If desk is true, then A remove the own property with name P from O. B return true, return false, 0, 1, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys, O1, 0, 1, 1, 1, 1 ordinary own property keys. O, the abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys 5. Return keys, 0, 1, 1, 2, ordinary object create, proto, additional internal slots list. The abstract operation ordinary object create takes argument proton object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal SL slots list. Let OB make basic object. Internal slots list. Set O to proto. Return O. 0, 1, 1, 3 ordinary create from constructor. Constructor. Intrinsic default proto. Internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor. Constructor. Intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create. Proto. Slots list. 0, 1, 1, 4 get prototype from constructor. Constructor. Intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get. Constructor. Prototype. If proto is not an object, then a let realm be. Get function realm. Constructor. B set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174, ECMA International 2024. Note: if constructor does not supply a value, the default value that is used is obtained from the EOM of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Oh, internal slot. The abstract operation require internal slot takes arguments O, an ECMA script language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMA script function objects. ECMA script function objects encapsulate parameterized ECMA script code closed over a lexical environment and support the dynamic evaluation of the code. An ECMA script function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMA script function object may be either strict mode code, 1122, or non-strict code. An ECMA script function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to ECMA script function objects also have the internal slots listed in Table 30. Table 30, internal slots of ECMA script function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMA script code. A parse node. The root parse node of the source text that defines the function's body. Constructor kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode. Lexical, strict, or global. Defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed T. Out object, copyright sign, ECMA International 2024. 75. Table 30, internal slots of ECMA script function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name. A string, a symbol, a private name, or empty. If the function is created as the initializer of the class field, the name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMA script function objects have the internal method defined here. ECMA script functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMA script function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If f is true, then a let error be a newly created type error object. B note, error is created in callee context with f's associated realm record. C remove callee context from the execution context stack and restore caller context as the running execution context. D return throw completion. Error. Perform ordinary call binds this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 prepare for ordinary call. F. New target. The abstract CT operation prepare for ordinary call takes arguments f, an ECMA script function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMA script code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f. 1. If callee context is not already suspended, suspend callee context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note, any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. To ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMA script function object, callee context, an execution context, and this argument, an ECMA script language value, and returns unused. It performs the following steps when called. Let this mode be f. If this mode is lexical, return unused. Let callee realm be f. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert, global env is a global environment record. 3. Let this value be global env. Be else, I let this value be. To eject, this argument. 2. Note, to eject produces wrapper objects using callee realm. Assert, local env is a function environment record. Assert, the next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value, 0, return unused, 0, 2, 1, 3 runtime semantics, evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Function body, function statement list, return. Evaluate function body of function body with arguments function object and arguments list. Concise body, expression body, return. Evaluate concise body of concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body, function body, return. Evaluate generator body of generator body with arguments function object and arguments list. Async generator body, function body, return. Evaluate async generator body of async generator body with arguments function object and arguments list. Async function body, return. Evaluate async function body of async function body with arguments function object and arguments list. Async concise body, expression body, return. Evaluate async concise body of async concise body with arguments function object and arguments list. Initializer, assignment expression, assert. Arguments list is empty, assert. Function object is not empty. If is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object, else a let RHS be. Evaluation of assignment expression, be let value be. Get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert. Arguments list is empty, return. Evaluate class static block body of class static block body with argument function object, 0, 2, 1. For ordinary call evaluate body, f. Arguments list. The abstract operation ordinary call evaluate body takes arguments f, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of f with arguments f and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMA script function object f takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be f, if kind is base, then let this argument be. Ordinary create from constructor, new target, %object prototype %4. Let callee context be prepare for ordinary call, f, new target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, be let initialize result be completion, initialize instance elements. This argument, f, see if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore callee context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body, f. Arguments list. Remove callee context from the execution context stack and restore callee context as the running execution context. 0. If result is a return completion, then A if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else A return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0, 2, 3 ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype, an object, source text, a sequence of Unicode code points, parameter list, a parse node, body a parse node, this mode, lexical this or non-lexical this, env, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1, 0, 2, 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set f to strict. If this mode is lexical this. Set f to lexical 0, else if strict is true. Set f to strict 1, else. Set f to global 2. Set f to false 3. Set f to env 4. Set f to private env 5. Set f to get active script or module 6. Set f to the current realm record 7. Set f to undefined 8. Set f to a new empty list 9. Set f to a new empty list 0. Set f to empty 1. Let len be the expected argument counter parameter list 2. Perform set function length f len 3. Return f ECMA International 2024 179 1 0 2 4 capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert realm existent has been initialized. Let thrower be realm. Perform define property or throw f caller property descriptor t thrower enumerable false true. Perform define property or throw f arguments property descriptor thrower enumerable false true. Return unused 0 2 4 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0 2 5 make constructor f writable prototype prototype. The abstract operation make constructor takes argument f, an ECMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMA script function object, then a assert is constructor f is false. B assert f is an extensible object that does not have a prototype own property. C set f to the definition specified in 1 0 2 2 else. A set f to the definition specified in 1 0 3 2 set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create %object prototype %. B perform define property or throw prototype constructor property descriptor f writable prototype false true. Perform define property or throw f prototype property descriptor prototype writable prototype false false. Return unused 80 ECMA International 2024 1 0 2 6 make class constructor f. The abstract operation make class constructor takes argument f, an ECMA script function object, and returns unused. It performs the following steps when called. Assert f is false. Set f to true. Return unused 0 2 7 make method f home object. The abstract operation make method takes arguments f, an ECMA script function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object. Return unused 0 2 8 define method property home object key closure enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert home object is an ordinary extensible object. If key is a private name, then a return private element. Method closure 3 else a let desk be the property descriptor closure true enumerable true. B perform define property or throw home object key desk. C note define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused 0 2 9 set function name f name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description the name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description, and else if name is a private name. Then a set name to name. If f is an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space a name. B if f is an internal slot, then I optionally set f to name. Perform. Define property or throw f name property descriptor name false enumerable false true return unused. ECMA International 2024 181 the 10th of February 2010 set function length f length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, j or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f length property descriptor length false enumerable false true return unused. 0 2 1 1 capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I func arguments list. The abstract operation capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated. In that environment record, each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let corny context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do, if D is neither a variable declaration nor of the binding nor a binding identifier, then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then, a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then, a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then, if function names contains arguments or lexical names contains arguments, then, I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then, a note, only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval, bl0ws be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. Let callee env be the lexical environment of callee context. See let env be new declarative environment. Callee env, deassert. The variable environment of callee context is callee env. Set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared be env has binding. Param name, be note, early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding, param name, undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object, arguments list, else. I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env, see if strict is true, then I perform env create a mutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. Else, I perform env create mutable binding, arguments, false. Perform env initialize binding, arguments. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then I perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else, I perform iterator binding initialization of formals with arguments iterator record and env 27. If his parameter expressions is false, then, I note, only a single environment record is needed for the parameters in top-level vars. Let instantiated var names be a copy of the list parameter bindings. See for each element n of var names. Do, if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding, n, false. Perform env initialize binding, n, undefined. Let var env be env 28. Else, I note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. Let var env be new declarative environment, env. C set the variable environment of callee context to var env. Let instantiated var names be a new empty list. For each element n of var names. Do, if instantiated var names does not contain n, then ECMA International 2024 183. 1. Append n to instantiated var names. Perform var env create mutable binding, n, false. If parameter bindings does not contain n, or if function names contains n, then a, let initial value be undefined 4. Else, a let initial value be env get binding value, n, false. Perform var env initialize binding, n, initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb, 3, 2, 1 adds additional steps at this point. 0. If strict is false, then a let lexi-env be new declarative environment, var env. B note, non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scope declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexi-env be var env. 2. Set the lexical environment of callee context to lexi-env. 3. Let lex declarations be the lexically scope declarations of code. 4. For each element d of lex declarations, do, a note, a lexically declared name cannot be the same as a function generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d, do, if this constant declaration of d is true, then perform lexi-env create a mutable binding, dn, true 2. Else, perform lexi-env create mutable binding, dn, false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do, a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexi-env and private env. C perform var env set mutable binding, fn, fo, false. 7. Return unused. 0.3 built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1, 0, 3, 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in the specification explicitly sets its internal method. Such an internal method must conform to the definition in 1, 0, 3, 2. An implementation may provide additional built-in function objects that are not defined in the specification. Note 2b, 3.2 provides an extension to the above algorithm that is necessary. Y for backwards compatibility with web browser implementations of ECMA script that predate ECMA script 2015. 84. Copyright sign, ECMA International 2024, 1031. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f, this arguments list, undefined 1, 0, 3, 2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs
Okay, so like,
return, built-in call or construct.
There's a desktop texture image,
New target 103. 3 built-in call or construct.
and then there's texture image.
New target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument
Well, they're both the same thing.
language value or uninitialized arguments list, a list language values, and new target. A constructor undefined and returns either a normal completion containing an ECM
The name is like
completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation.
VK image.
Callee context. Push callee context onto the execution context stack. Callee context is now the running execution context.
VK image view.
That is the result of evaluating.
VK device memory.
This argument is uninitialized. The this value is uninitialized.
VK sampler.
This argument provides the this value arguments list, provides the named parameters, new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and
So this is really annoying. This is like really annoying.
3. For create built-in function, behavior,
So basically though,
internal slots list, realm,
I have two.
abstract
I
operator,
have one of these and one of these by this type.
an abstract closure,
As a name, I don't know what the name is. I gotta check.
functions behavior,
So I know these are related,
a non-negative integer or plus,
and then these are related,
and additional internal slots list, a list of names of internal slots, and optional
and then the name.
prototype, an object or null.
So these two are related,
A function object additional internal slots list.
but it's like image, memory.
Callee context is removed from the execution context stack. It must not
These two are not related,
will generate affiliate
but it's like image, then image view,
85 be defined
because image relates to image view,
function object.
and device memory relates to sampler.
Set realm to the current realm record.
Holy crap,
Set prototype.
this is frustrating.
Be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new
What the heck is a sampler?
called performs the action described by behavior.
So I have these two.
The new function object has internal slots whose names are the elements of internal slots list and an internal slot. Set func to prototype. Set func to true. Set func to realm. Set func to null. 0. Perform set function length.
I have to just name it something.
This is not present. Then a perform set function name. Func. Name 12. Else a perform set function name. Func. Name.
Oh, I can name it snap.
Turn func. Each built-in function defined in this
That's easy. Snap.
function abstract operation.
I'm not gonna mix that up with anything.
And slots. This specification
It's completely like, there's no way anything is named snap.
objects except for a few
I
specific
could see take, film, or shot all being used in the namespace, but not snap.
specified otherwise below. 0.
And then you like crackle and pop.
Exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function.
And then the name gives away that these two are related,
Applicable. Internal methods use
and these two are related.
and its other essential internal methods use the definitions found in 10.1. The
Because it's desktop texture, desktop texture.
function exotic objects do not have the internal slots of ECMA script function object.
Oh, this is so confusing.
Instead, they have the internal slots listed in Table 31. In addition to Table 31, internal slots of bound function exotic objects. Internal slot type description bound target function a callable object the wrapped function object bound this an ECMA script language value the value that is always passed is the this value when calling the wrapped function bound arguments a list of ECMA script language values a list of values whose elements are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 10411. This arguments list. The internal method of a bound function exotic object f takes arguments. This argument an ECMA
This one's named VK sampler.
list of ECMA script language values
Does that have anything to do with texture?
meaning an ECMA script language value or a throw completion. It performs target bf let bounds this bf let bound args bf let args be the list concatenation of bound args and arguments list. Return call target bounds this args 0 4 1 2 arguments list new target. The internal method of a bound function exotic object f takes arguments list a list of ECMA script language values a new target a constructor and returns either a normal completion containing an object.
Intermediate is too long a word.
Let target bf as
It's too long to type up.
target is true. Let bound arg
Between.
is concatenation of bound args and arguments list. If same value f new target is true. Set new target to target. Return
It's kind of creepy.
args new target 0 4 1 3 bound function create target function, bound this, bound UGS. The abstract operation bound function create takes arguments target function, a function object, bound this, any CNA
I just need a word
script.
to rename this crap.
Returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1 0 4 1 1. If this constructor target function is true, then a set obj as described in 1 0 4 1 2. Set obj to target function. Set obj to bound this. Set obj to bound UGS 0. Return obj 0 4 to array exotic objects. An air I is an exotic object that gives special treatment to array index property keys C6 1 7. A property whose property name is an array index is
Nice job, bud. Are they paired like this?
property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use
And is that subsampler? Is that a buffer?
create, 0, 4,
Or is that a handle?
desk, the internal method of an array
I would assume it's a buffer. Because it... Oh, this is so stupid.
for a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return.
What's your handles and what's your buffers?
Else if p is an array index, then a let length desk be ordinary get own property, a, length, b assert, is data descriptor, length desk, is true, c assert, length desk is false, d let length be length desk, b assert, length is a non-negative integral number, f let index b, 32, p, g if index length and length desk is false, return false, h let succeeded b, ordinary define no,
And it says that
b, desk, I have succeeded is false,
the subtexture image
then,
GPU resource filled from system capture.
needed to, ordinary define no,
Texture image CPU image sampled in shader.
it is true, k return true, return, ordinary define known property, a, p, desk, 0, 4, 2, to array create, length, proto, the abstract operation array create takes argument length, a non-negative integer, and optional argument proton object, and returns either a normal completion containing an array exotic object or a throw completion.
So one of them's for sending, the other one's for receiving.
It performs the following steps when called. If length, 232 1, throw a range error exception. If proto is not present, set proto to percent array prototype percent. Let a be make basic object. Set a to proto, set a is specified in 1 0, 4, 2, 1. Perform. Ordinary define known property, a, length, property descriptor, length, true, false, false. Return a, 0, 4, 2.
So that's subtexture image
The abstract operation array species create takes arguments original array.
is higher up in the pipeline because it's the input source of the pixel data copied from the screen.
It is used to specify
It may then be copied or transitioned into texture image.
to enforce that the constructor function returns an array. It performs the following steps when called. Let is array be, is array, original array. If this array is false, return. Array create, length.
Oh, this is so annoying.
Original array, constructor. If this constructor, C, is true, then 88. ECMA International 2024. Let this realm be the current realm record. B let realm be. Get function realm, C. See if this realm and realm are not the same realm record. Then, I have same value, C, realm is true. Set C to undefined. If C is an object, then set C to get C at species. B if C is null, set C to undefined. If C is undefined, return. Array create, length. If this constructor, C, is false, throw a type error exception. Return. Construct, C, length, 0, 4, 2, 4 array set length, A, desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a
I gotta figure out how to make
steps when called. If desk does not,
texture image a copy, not a clone. I mean,
desk will be a copy of desk.
make it a pointer to the other one
Desk, let number len be, to number, desk,
instead of a copy.
n, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property, A, length, assert, is data descriptor. Old len desk, is true, assert. Old len desk is false, 0. Let old len be old len desk, 1. If new len old len, then a return. Ordinary define known property, A, length, new len desk, 2. If old len desk is false, return false, 3. If new len desk does not have a field or new len desk is true, then a let new writable be true, 4. else. A note, setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new lendesk to true. 5. Let succeeded be. Ordinary define known property, A, length, new lendesk. 6. If succeeded is false, return false. 7. For each own property, y keepy of a such.
So this is screen capture copy.
32. P, new len, in descending, numeric index order. Do, a let delete succeeded B. A, P, B if delete succeeded is false, then I set new lendesk to. 32. P plus 1, 2. If new writable is false, set new lendesk to false. 3. Perform. Ordinary define known property, A, length, new lendesk. 5. Return false. 8. If new writable is false, then assert succeeded to. Ordinary define known property, A, length, property descriptor, false. B assert, succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1, 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, S, P. If desk is not undefined, return desk. Return string get own property, S, P, 0, 4, 3, 2, P, desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property, S, P. If string desk is not undefined, then a let extensible be S. P return is compatible property descriptor, extensible, desk, string desk, ret, an, ordinary define known property, S, P, desk, 0.
Oh, that's annoying.
The internal method of a string exotic object O takes no arguments and returns a normal.
You do always one thing.
The following steps when called. Let keys be a new empty list. Let strbo assert str.
You have image info.
R free.
Pass in the sampler and the image view, and also the image layout. Versus these two. This is a flag.
P is an array indexant. To integer or infinity, P, len, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do A append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do A append P to keys. 9. Return keys 0, 4, 3, 4 string create, value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic.
No, I'm not going to rename these.
Set S to value.
I'm just going to leave them.
Specified in 1, 0, 4, 3, 1. Set S is specified in 1, 0, 4, 3, 2. Set S is specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5 string get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If its integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be S, assert, str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r, index plus 1, 1. Return the property descriptor, result str, false, true, false, 0, 4. 4 arguments exotic objects. Most ECMA script function.
So this one's a handle, for sure.
Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object.
I had to carefully replace or rename the couple places. I think just these top two I have. These ones I don't. And I'll be done with this. I just want to be done. still have to like render the stupid movie to put in the background for the frame of it. This one's data, pixel data. Then handle. This is so boring. Alright, it's almost done. As long as this works, I'll be good. It's probably not gonna work. Oh my god, I hate this so much. This freaking sucks. Chatbot, it can't even bit shift. It's pathetic. Spin. Oh, this is so boring. I want to do something more exciting already. I want to like edit the video or anything other than this.
Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal, integer literal, non-octal decimal, integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note to non-strict code. This syntax is legacy. 2, 9, 3, 2 static semantics, MV. A numeric literal stands for a value of the number type or the big int type. The MV of decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits. Decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 28. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or of binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit. The MV of decimal digit. 6 or of non-zero digit. The MV of decimal digit. 7 or of non-zero digit. The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit. Or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4. 5 or of hex digit. 5 or of octal digit. 5 is 5. 6 or of hex digit. 6 or of octal digit. 6 is 6. 7 or of hex digit. 7 or of octal digit. 7 is 7. 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separator binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L. Non-octal digit is the MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L octal digit is the MV of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L times 10 plus the MV of octal digit. The MV of hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2 9 3 3 static semantics. Numeric value. The syntax directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions: numeric literal, decimal literal, return round MV result, MV of decimal literal, numeric literal, non-decimal integer literal, return, MV of non-decimal integer literal, numeric literal, legacy octal integer literal, return, MV of legacy octal integer literal, numeric literal, colon non-decimal integer literal big int literal suffix, return the big int value for the MV of non-decimal integer literal, ECMA International 2024 229, decimal big integer literal, 0 big int literal suffix 1, return 0z, decimal big integer literal, non-zero digit big int literal suffix 1, return the big int value for the MV of non-zero digit, decimal big integer literal, non-zero digit decimal digits big int literal suffix, non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the MV of non-zero digit 10n plus the MV of decimal digits. Return z, MV 2 9 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2 code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence, 30, ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFN RTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4,567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, x hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1, ECMA International 2024 231. Note 2, LF, and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2, 9, 4, 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2, 9, 4, to static semantics, SV. The syntax directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1293. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028, line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029, paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028, line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029, paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7, use strict. 32, copyright sign, ECMA International 2024, table 38. String single character escape sequences. Escape sequence, code unit value, Unicode character name, symbol B 0 times 0008, backspace BS T 0 times 0009, character tabulation HT N 0 times 000 line feed LF V 0 times 000B, line tabulation VT F 0 times 000C, form feed FF R 0 times 000D, carriage return CR, double quote 0 times 0022, quotation mark, apostrophe 0 times 0027, apostrophe, backslash 0 times 005C, reverse solidus, comma. The SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence, 8 is the string value consisting of the code unit 0 times 0038, digit 8. The SV of non-octal decimal escape sequence, 9 is the string value consisting of the code unit 0 times 0039, digit 9. The SV of hex escape sequence, x hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits, Hexdigit, 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 hexdigit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0, 0, 0, 0, null 1, 2, 9, 4, 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0, the MV of 0 to 3. 1 is 1, the MV of 0 to 3. 2 is 2, the MV of 0 to 3. 3 is 3, the MV of 4 to 7. 4 is 4, the MV of 4 to 7. 5 is 5, the MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The P reductions below describe the syntax for a regular expression literal and are used by the input elements and are to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2 2 2 1. An implementation may extend the ECMA script regular expression grammar defined in 2 2 2 1, but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars, empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminated but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, regular expression char, regular expression non-terminated but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars, empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminated but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Note 1: a regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. See 22.2 4 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char. 2 9 5 1 static semantics. Body text. The syntax directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1 2 9 5. To static semantics. Flag text. The syntax directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1 2 9 6. Template literal lexical components. Syntax: template, no substitution template, template head, no substitution template, template character sop, template head, template character sop, $, template substitution tail, template middle, template tail, template middle, template character sop, $, template tail, template character sop, template characters, template character, template character sopt. Note: 2 regular expression literals may not be empty empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use .dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $sign or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead. Not code point. Hex digits. SEP. But only if MB of hex digits. 0 times 10FF. Code point. Hex digits. SEP. But only if MB of hex digits 0 times 10FF. Note template substitution tailors used by the input element template tail alternative lexical goal 1 2 9 6 1 static semantics TV. The syntax directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $sign, is the empty string. The TV of template middle, $sign, is the empty string. The TV of template tail is the empty string. The TV of template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $sign is the string value consisting of the code unit 0 times 0024. $sign, the TV of template character, template escape sequences the SV of template escape sequence. The TV of template character, not escape sequence is undefined. The TV of template character, line terminator sequences the TRV of line terminator sequence 236. Copyright sign, ECMA International 2024, the TV of line continuation, line terminators, sequence is the empty string 1 2 9 6 to static semantics, TRV. The syntax directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $sign, is the empty string. The TRV of template middle, $sign, is the empty string. The TRV of template tail is the empty string. The TRV of template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $sign is the string value consisting of the code unit 0 times 0024. $sign, the TRV of template character, template escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence. The TRV of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence. The TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0. The TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit. The TRV of not escape sequence, X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter X. The TRV of not escape sequence, X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter X, and the TRV of hex digit. The TRV of not escape sequence, U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter U. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U. The TRV of the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U. The TRV of the first hex digit. The TRV of the second hex digit. and the TRV of the third hex digit. The TRV of not escape sequence, U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the code unit 0 times 007b, left curly bracket. The TRV of not escape sequence, U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007b, left curly bracket, and the TRV of not code point. The TRV of not escape sequence, U,
So like,
is the string concatenation of the code unit 0 times 00
I'm gonna check which of these are VK image,
left curly bracket,
and then VK device memory.
digit 1 of 0 1 2 3 4 5 6 7 8 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence, non-escape
And then rename everything in this current file
character 1 of BF.
to this name with desktop in it, so it's easier to like freaking read.
This production, the TRV of
Because texture, memory,
string concatenation of the
texture image,
TRV of
texture image, same thing. I don't even know. It's so annoying to read.
sequence, U hex 4 digits is the string concatenation of the code unit 0 times 0075, Latin small letter
And then the other two, I'll just use whatever name that's in place. I bit my tongue.
is the
I can't talk.
unit 0 times 0075, Latin small letter U, the code unit 0 times 007b, left curly bracket, the TRV of ECMA International 2024-237, code point, and the code unit 0 times 007d, right curly bracket, the TRV of hex 4 digits, hex digit, hex digit, hex digit,
Okay, so VK image is texture image
hex digit,
and a texture image memory. That's what I got.
hex digit is the string concatenation of the TRV of hex digits and the TRV
I know that these two relate to only
789 of
the desktop image that's being blitzed to the 2D plane, whatever.
the TRV of line continuation, line terminator sequence,
So these need to go
0 times 005c, reverse solidus, and the TRV of line terminator sequence, the TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed, the TRV of line terminator sequence, CR is the string value consisting of the code unit 0 times 000 line feed, the TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2000,
Oh, this is so annoying.
the TRV of line
So you got texture image here,
is the string value consisting of the code unit
goes into create image,
paragraph separator, the TRV of line terminator sequence, CRLF, is the string value consisting
and you got texture image memory.
line feed 2.10 automatic semicolon insertion. Most ECMA scripts
That goes into,
with a semicolon. Such
so it's allocate, bind,
for convenience. However, such semicolons may be omitted from the source text.
and this one's just create.
These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.
Oh, this is so frustrating.
On insertion, in the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar.
Okay, so here, so texture image and texture image memory,
Token is separated from the
these two,
one-line terminator. The offending token is the previous token
they're related for sure.
can be passed as the terminating semicolon.
Because right here is texture image,
2. When, as the source text is passed from left to right, the
and right here is texture image memory.
is unable to pass the input token stream as a single instance of the
And I know that this is a handle to this one.
input stream. When, as the source
So those two are related.
a token
So I'm gonna name them to make it like real obvious that they're related.
production in the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV
Like scroll down to double check.
TRV includes them, CR, LF, and CR line terminator sequences are normalized to LF.
Yeah, that's the only place it's used, okay.
Explicit template escape sequences needed to include a CR or CR, LF. Sequence 38, ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted
So rename everything in my file,
statement or if that semicolon
all these.
in the header of a for statement C14, 7, 4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression, yield, await.
To the new name.
Plus, plus.
I just want to be done.
No line terminator here. Continue statement, yield, await. Continue, continue. No line terminator here. Label identifier, yield, await. Break statement, yield, await. Break, break. No line terminator here. Label identifier yield await. Return statement. Yield await. Return. Return. No line terminator here. Expression. Class in yield await. Throw statement. Yield await. Throw. No line terminator here. Expression. Class in yield await. Yield expression. In await. Yield. Yield. No line terminator here. Assignment expression in. Class yield await. Yield. No line terminator here. Assignment expression in. Class yield await. Arrow function. In. Yield await. Arrow parameters yield await. No line terminator here. Equals. Concise body in. Async function declaration. Yield await. Default. Async.
Alright, so it's gonna be named to this.
Function binding identifier yield.
Desktop texture, image, and desktop texture. Memory.
Default. Async. No line terminator here. Function. Form.
I'm not even gonna rename it.
Async function.
That works.
Expression.
Except I am going to.
Binding identifier. Yield. Class await opt. Formal parameters. Yield. Class await. Async function body. Async method. Yield. Await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Yield. Class await. Async function body. Async generator declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Class yield. Class await. Async generator body. Class default. Async. No line terminator here. Function. Formal parameters. Class yield. Class await. Async generator body. Async generator expression. Async. No line terminator here. Function binding identifier. Class yield. Class await opt. Formal parameters. Class yield. Class await. Async generator body. Async generator method.
I mean, like,
Async.
texture and text are like the same freaking word.
Unique formal parameters. Class yield. Async generator body. Async
You just name it tier.
await. Async. No line terminator here. Async arrow binding identifier.
Tier that looks like texture.
Async concise body in.
You know what? I'm gonna do it. It's be called tier. I just decided I'm gonna name it tier.
Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Yield await. No line terminator here. Equals. Async concise body in. ECMA International 2024 239. Async arrowhead. Async. No line terminator here. Arrow formal parameters. Yield. Class await. The
So I'm gonna name it my desktop tier image and my desktop tier mem for texture.
line terminator occurred between the preceding token and the plus plus or token. Then a
Do you even need the E?
for the plus plus or.
Yeah, I do.
Continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token. A semicolon is automatically inserted after the continue, break.
It's a real stupid name, but I don't care.
When arrow function parameter s are followed by a line terminator before it equals token, a semicolon is automatically inserted and the punctuator causes a syntax error.
Say the old name after it.
Before a function or identifier name or token, a semicolon is automatically inserted in th. The async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error.
I'll call this one handle.
CMA script programmers is a postfix plus plus or operator should be on the same line as it.
This one buffer.
And in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in
It's got handle
same line as the break or continue to
and buffer.
functions parameter s and its equals should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2, 1, 0. Two examples of automatic semicolon insert.
There we go. Super fancy.
12, 3 is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source 1, 2, 3 is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMA script sentence. The source 4A B 40 copyright sign ECMA International 2024 is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source return a plus B is transformed by automatic semicolon insertion into the following return
It's so stupid. An image and then memory.
by automatic semicolon insertion into the following up equals B.
That makes it so annoying.
B LC equals D is not a valid ECMA script sentence and is not
Because the image isn't even the image, it's like a handle.
even though no production
And the memory, it's like buffer.
automatically inserted
But the second one,
as an empty statement. The source
you know, it doesn't matter. This stuff is so annoying.
by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call up equals b plus c.
I'll name it then, get over with.
Circumstance that an assignment statement must begin with a left parenthesis. It is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2, 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus plus. ECMA International 2024-241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of
So cut this, paste it to the file.
colon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2, 1, 0. 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many
Why don't I just make another new file?
which may be omitted using automatic semicolon insertion. As a consequence of the rules above,
Just make all the new files.
colon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, unary plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be part
Alright, so rename.
of operator. For example, if the regexp has flags 2, 1, 0, 3,
Dang it.
semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here in this version of ECMA script. 2, 1, 0. 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2, 42, ECMA International 2024, 13 ECMA script language, expressions, 3.1 identifier syntax, identifier reference, yield, await, identifier, yield, await, binding identifier, yield, await, identifier, yield, await, label identifier, yield, await, identifier, yield, await, identifier.
Relax the outer block.
3, 1, 1 static semantics, early errors, binding identifier, It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval, identifier reference, yield binding identifier, yield label identifier, yield. It is a syntax error if the source text matched by this production is contained in strict mode code, identifier reference, await binding identifier, await label identifier, await. It is a syntax error if the goal symbol of the syntactic grammar is module, binding identifier, yield, await, yield. It is a syntax error if this production has a yield parameter, binding identifier, yield, await. ECMA International 2024-243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter, identifier reference, yield, await, identifier binding identifier, yield, await, identifier label identifier, yield, await, identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier
I'm already editing the wrong function.
3, 1, 2 static semantics, string value. The syntax directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier code points of identifier name, return code points to string, text unescaped, identifier reference, yield binding identifier, yield label identifier, yield.
I split one function up into two.
Await binding identifier, await label identifier, await, return await, identifier.
To make sure I have a backup of something that works.
Turn the string value of identifier
Now I'm like mixing them up.
name.
I'm trying to like update one of them.
0023, number sign, and the
so I don't mess up the original one.
literal 1.
I'm like typing in the original, messing it up right now.
Any Unicode ESCA. Pay sequences an identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024. 131. 3 Runtime Semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression. Yield. Await. This. Identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Expression plus and yield await. Expression plus and yield await. Dot. Binding identifier yield await. Dot. Binding pattern yield await. Expression plus and yield await. Binding identifier yield await. Expression plus and yield await. Binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024-245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await. The interpretation of capital C O
I should ignore this.
E R, capital P A R E N T H E S
For this one.
D, capital E X P R E S S I N, capital A N, is refined using the following grammar. Parenthesized expression, yield, await, expression, plus and yield await. 3, 2,
For this one, ignore this.
2, 1. 1 runtime semantics. Evaluation. Primary expression. This. Return. Resolve this binding. 3, 2. 2 identifier reference. C13.1 for identifier reference 1, 3, 2. 3 literals. Syntax. Literal. Null literal. Boolean literal. Numeric literal. String literal. 3, 2. 3. 1 runtime semantics. Evaluation. Literal. Null literal 1. Return null. Literal. Boolean literal. If boolean literal is the token false, return false. If boolean literal is the token true, return true. Literal. Numeric literal. Return the numeric value of numeric literal as defined in 1, 2, 9, 3. Literal. String literal. Return the SV of string literal as defined in 1.
So inner block was here, I think.
46. ECMA International 2024. 1, 3, 2. 4 array initializer. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element count rebutes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal. Yield. Await. Elision ort. Element list yield await. Element list yield await. Elision ort. Element list. Yield. Await. Elision ort assignment expression. Plus and yield await. Elision ort spread element yield await. Element list yield await. Elision ort assignment expression. Plus and yield await. Element list yield await. Elision ort spread element yield await. Elision. Elision. Spread element. Yield. Await. Dot. Assignment expression. Plus and yield await. 1, 3, 2. 4. 1 runtime semantics. Array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next in
So we need these first.
either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232. 1. Return len. Elision. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision ort assignment expression. If elision is present, then as set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string. Next int x. Init value. Return next index.
Done this one.
Is is an expression describing the initial
I think organized, whatever.
or more expressions, each of which
I just have to carefully figure out what goes where.
need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2000
Because I'm almost done.
list, eligible spread element,
I'm not totally sure how all this stuff, how it connects and stuff.
arguments array and next index, return, array accumulation of spread element with arguments array and next index,
So if I don't rush, I won't break anything.
set next index 2, array,
Well, stuff will break, but it won't end up being worst case every time.
set next index 2, array accumulation of elision with arguments array and next index, let init result be, evaluation of assignment expression, let init value be, get value, init result, perform, create data property or throw, array, to string, next int x, init value, return next index plus 1, element list, elision spread element, set next index 2, array accumulation of element list with arguments array and next index, if elision is present, then, set next index 2, array accumulation of elision with arguments array and next index 3, return, array accumulation of spread element with arguments array and next index, spread element, assignment,
So that's not found here.
evaluation of assignment expression, let spread obj be, get
I gotta rename these.
let iterator record b, get iterator, spread obj, sync, repeat, let next b, iterator step value, iterator record, b if next is done, return next index, c perform, create data property or throw, array, to string, next int x, next, d set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified.
Dang it, there's another thing.
New own properties using 3, 2, 4, 2, runtime semantics, if
How many handles to the same exact thing could possibly
present,
be needed?
array accumulation of elision with arguments array and 0,
Ridiculous.
array literal, element list, let array be, array create, 0, perform, array accumulation of element list with arguments array and 0, return array literal, element list, elision ort, 2, let array be, array create, 0, let next index be, array accumulation of element list with arguments array and 0, 48, ECMA International 2024, 3, if elision is present, then, perform, array accumulation of elision with arguments array and next index, return array, 3, 2, 5 object initializer, syntax, object literal, yield, await, property definition list yield await, property definition list yield await, property definition list, yield, await, property definition yield await, property definition list yield await, property definition
So done.
yield, await, identifier reference yield await, cover initialize name yield await, property name yield await, assignment expression, class and yield await, method definition yield await, dart, assignment expression, class and yield await, property name, yield, await, literal property name, computed property name yield await, literal property name, identifier name, string literal numeric literal, computed property name, yield, await, assignment expression, class and yield await, cover initialized name, yield, await, identifier reference yield await, initializer, class and yield await, initializer, in, yield, await, assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0
Paces here.
associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign, ECMA International 2024-249. Note 3 in certain contexts. Object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary.
These are defined.
However, the use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics, early errors, property definition, method definition, bullet. It is a syntax error if has direct super.
This one.
It is a syntax error if private bound identifiers of method definition is not empty. In, used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N or capital C O V E R capital C A L L capital E X P R E
So image view.
N capital A N D capital A S Y N C capital A R R property definition cover initialized name. It is a syntax error if any source text is matched by this production. Object literal property definition list. Property definition list. It is a syntax error if property name list of property definition list contains
Oh, why is this so confusing?
entries properties were obtained from productions of the form property definition, property name, assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax directed operation is computed property key takes no arguments.
So attachments is an array that has one count, that has image views.
Return false. Property name.
Okay, so it's not that confusing.
To describing an actual object initializing the object literal productions are also 250 ECMA International 2024. Note 1. This production exists
Except VK image view.
grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The
I guess it's technically an array of them.
property names defined using a computed property name. 1, 3, 2, 5. 3. Static semantics. Property name list. The syntax directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return
Assigned to malloc too.
definition of list and prop name. 3.
It's funky.
For runtime semantics, evaluation, object literal, return ordinary, object create, object prototype, object literal, property definition list, let obj be ordinary, object create, object prototype, perform. Property definition evaluation of property definition list with argument obj, return obj, literal property name, identifier name, return string value of identifier name, literal property name, string literal 1. Return the SV of string literal property name, numeric literal, let NBR be the numeric value of numeric literal, return. To string, NBR, computed property name, assignment expression, let X per value be. Evaluation of assignment expression, let prop name be. Get value, X per value, return. To property key, prop name, 3, 2, 5. 5. Runtime semantics, property definition evaluation. The syntax directed operation property definition evaluation takes argument object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list.
Some pieces here.
Definition, perform. Property definition evaluation of property definition list with argument object, perform. Property definition evaluation of property definition with argument object, return unused. ECMA International 2024 251. Property definition, assignment expression, let X per value be. Evaluation of assignment expression, let from value be. Get value, X per value, let excluded names be a new empty list, perform. Copy data properties, object, from value, excluded names, return unused. Property definition, identifier reference, let prop name be string value of identifier reference, let X per value be. Evaluation of identifier reference, let proper value be. Get value, X per value, assert. Object is an ordinary, extensible, object with no non-configurable properties, perform. Create data property or throw, object, prop name, prop value, return unused. Property definition, property name, assignment expression, let prop key be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse. Then, a let is proto set to be false, else if prop key is proto and is computed property key of property name is false, then a let is proto set to be true, else a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter is false, then a let proper value be. Named evaluation of assignment expression with argument prop key, else a
Let's replace.
evaluation of assignment expression, be let proper value be. Get value, X per value ref. If this proto setter is true, then if proper value is an object or proper value is null, then I perform object, proper value be return unused.
Replace with this.
Ordinary, extensible, object with no non-configurable properties, perform. Create data property or throw, object, prop key, prop
And see what happens.
N unused, property definition, method definition, perform. Method definition evaluation of method definition with arguments, object and true, return unused. 3, 2, 6 function defining expressions, see 15.2 for primary expression, function expression, see 15.5 for primary expression, generator expression, see 15.7 for primary expression, class expression, see 15.8 for primary expression, async function expression, see 15.6 for primary expression, async generator expression, 52, copyright sign, ECMA International 2024, 132, 7 regular expression literal syntax, C12, 9, 5, 3, 2, 7, 1 static semantics, early errors, primary expression, regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7.
The sampler is set to what?
Capital I, S, capital V, A, L, I, D, capital R, E, G,
The sampler info.
L, A, R, capital E, X, P,
What's sampler info set to?
S, S, I, O,
This stuff.
L, I, T, E.
And this is set to.
Abstract operation, capital I, S, capital
Oh, this is so frustrating.
I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U,
Alright, those were replaced.
be false. If flags contains V, let V be true.
Also, it says
Let pattern text be body text.
this might be bubble.
False. Then, a let string value be code points to string, pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern, pattern text, U, V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics, evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of
Do I need two of these?
turn. regexp create, pattern, flags, 3, 2, 8 template literal syntax, template literal, yield, await, tagged, no substitution template, substitution template yield await tagged, substitution template, yield, await, tagged, template head expression, plus and yield await, template spans yield await tagged, template spans, yield, await, tagged, template tail, template middle list yield await tagged, template tail, ECMA International 2024 253, template middle list, yield, await, tagged, template middle expression, plus and yield await, template middle list yield await tagged, template middle expression, plus and yield await, 3, 2, 8, 1 static semantics, early errors, template literal, yield, await, tagged, no substitution template. It is a syntax error tag.
Man, make two of them.
Substitution template contains not escape sequence, template literal, yield, await, tagged, substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument force is greater than or equal to 232. Substitution template, yield, await, tagged, template head expression, plus and yield await, template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans, yield, await, tagged, template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list, yield, await, tagged, template middle expression, plus and yield await, template middle list yield await tagged, template middle expression, plus and yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, to static semantics, template strings. The syntax directed operation template strings takes argument draw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template. Raw. Substitution template, template head expression template spans. Let head be template string, template head, raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans, template tail. Return template string, template tail, raw. Template spans, template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string, template tail, raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle, raw. Template middle list, template middle list template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics, template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRB of template token, else a let string be the TB of template token, return string. 3, 2, 8, 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do I f is the same parse node as template literal. Then I return e. Let raw strings be template strings of template literal with argument true. Assert. Raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert. Count 232 1. Let template be array create. Count 0. Let raw obj be array create. Count 1. Let index be 0. 2. Repeat. While index count a let prop be to string index be let cooked value be cooked strings index c perform. Define property or throw template prop property descriptor cooked value writable false true, false. D. Let raw value be the string value raw strings, index, E. Perform. Define property or throw, raw obj, prop. Property descriptor, raw value, false, true, false. F. Set index plus 1. 3. Perform. Set integrity level, raw obj, frozen. 4. Perform. Define property or throw, template, raw. Property descriptor, raw obj, false. Enumerable, false, false. 5. Perform. Set integrity level, template.
Okay, so
The record, template literal.
the desktop sampler
7. Return.
and the image view are like
Template token contains a not escape sequence.
the same, whatever,
Or 255.
or tightly coupled or something.
Routes
Two pieces, same pod,
template literal in the program code of a realm is associated with the
or tunnel buddies.
templates. 1, 3, 2, 8, 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMA script code. 1, 3, 2, 8, 5. Runtime semantics.
This isn't assigned anymore.
Syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Templates.
This is going by this name.
Tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let precede.
So I'll make these inside here too.
Middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return. The list concatenation of preceding and next. 3, 2, 8, 6. Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return a string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator.
Back is a set.
Template tail. Return the TV of template tail as
Since that init, this means it's good.
spans. Template middle list. Template tail. Let it be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return a string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return a string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return a string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2. Runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A
These two.
N T.
This is so annoying. I literally just have 2, 3 things to connect.
Capital E
I'm not sure which ones go where.
E S
They're all names same for the thing.
N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return. Evaluation of expa parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257 13.3 left-hand side expression syntax. Member expression, yield, await. Primary expression yield await. Expression yield await. Expression, plus and yield await. Member expression yield await. Identify name member expression yield await. Template literal yield await. Plus tagged. Super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier. Super property. Yield await. Super expression plus and yield await. Super. Identifier name, meter property, new target, import meter, new target, import meter, import meta, new expression, yield, await, member expression, yield, await, new expression, yield, await, call expression, yield, await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression, plus and yield await, call expression yield await, identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await, private identifier, super call, yield, await, super arguments yield await, import call, yield, await, import, assignment expression, plus and yield await, arguments, yield, await, argument list yield await, argument list yield await, 58, ECMA International 2024, argument list, yield, await, assignment expression, plus and yield await, dot. Assignment expression, plus and yield await, argument list yield await, assignment expression, plus and yield await, argument list yield await, assignment expression, plus and yield await, optional expression, yield, await, member expression yield await, optional chain yield await, call expression yield await, optional chain yield await, optional expression yield await, optional chain yield await, optional chain, yield, await, arguments yield await, expression, plus and yield await, identifier name, template literal yield await, plus tagged, private identifier, optional chain yield await, arguments yield await, optional chain yield await, expression, plus and yield await, optional chain yield await, identifier name, optional chain yield await, template literal yield await, plus tagged, optional chain yield await, private identifier, left-hand side expression, yield, await, new expression.
Okay, got it. I got the perfect name.
Expression yield await, supplemental syntax, when processing an instance of the production, call expression, capital C, O, V, E, R, capital C, A, L,
Alright, so
E, X,
this is swap chain, but it's not really a swap chain.
I,
It's a desktop sampler. I don't even know what that means.
D, capital A,
Apparently that means
C, capital
sampling settings.
R, the
It's related to the view of the image. To the view of the image.
R, capital C,
So this exposes it to shaders.
capital E,
This is how textiles are fetched.
E, S, S,
And these are both handles.
capital A, N, D,
But the other two is a handle and data.
N, C, capital A, R, R, is refined using the following.
So I'm gonna rename it like this.
Member express
And then I'm gonna leave it. And I should be able to like type it in, run it, and see if it builds.
1 static semantics, early errors, optional chain, template literal, optional chain template literal. It is a syntax error if any source.
Do I want the A?
MAR International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code.
I'll keep the letter A, so it's a different length.
The purpose is to
So this way I call it snap instead of image.
C, which is a valid statement and where automatics.
And then it's like not the image, so I won't mistake it for being memory.
3, 2 property accesses. Note properties are accessed by name.
That is the image like data, not like pixel data.
Call expression.
And swap means swap chain.
Expression. Call expression.
But it can mean like any kind of swap. So that's like ambiguous.
Identifier name.
And then snap, because they're both like kind of related, but not really.
And similarly, call
But they are. But they're not.
behavior 2. Call expression. Identifier name string.
Samp for sample,
To evaluating string value of identifier.
but this one's a handle.
1 runtime semantics. Evaluation. Member expression. Member expression. Expression. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If the source text matched by this member.
That's just as messy to read, but
Let strict be.
at least nothing else is named like this.
E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C E S S capital W I T H capital E X P R base value expression strict 60 ECMA International 2024 member expression identifier name let base reference B evaluation of member expression let base value B get value base reference if the source text match by the
Maybe I should spell like texture.
strict be true else let strict be false return capital E V
I'm gonna do tier.
A T E
Alright, could rename this. I'm done.
O P E
I can run it.
T Y cap
If it doesn't run, I'll be pissed.
S S capital W
This is my last time renaming for no reason.
E N base value
It's going to run anyways.
strict member expression member
But after looking at what attaches to what, I would assume this might work.
reference let field name string be the string value of private identifier return make private reference base value field name string call expression expression let base reference be evaluation of call expression let base value be get value base reference if the source text match by this call expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name let base reference B evaluation of call expression let base value B get value base reference
Okay, can rename it. No going back.
let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R
I already renamed all these.
C C E
So all I have left is this,
capital W I T H capital I
which is right here.
base value identifier name
Got this one.
call expression private identifier let base reference B evaluation of call expression let base value B get value base reference
Just use everywhere.
be the string value of private identifier return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital
I don't know. This looks easier than this.
E X P
So rename it, then run it. I really hope it works.
expression an expression parse node and strict a boolean and returns either a normal completion containing a
I gotta move this global next to this global.
name reference B evaluation of expression let property name value B get value property name reference let property key B to property key property name value return the reference record base value property key strict this value empty 3 4 capital E V A L U A T E capital P R O P
Move it up here.
T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N takes arguments base value an ECMA script language value identifier name an identifier name parse node and strict a boolean and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name. Return the reference record. Base value property name string strict empty ECMA International 2024 261 133 5 venue operator 3 3 5 1 runtime semantics evaluation new expression return evaluate new expression empty member expression new member expression arguments 1 return evaluate new member expression arguments 3 3 5 1 1 evaluate new construct expr arguments the abstract operation evaluate new takes arguments construct expr a new expression parse node or remember expression parse node and arguments empty or an argument parse node and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Let ref B Evaluation of construct expa. Let constructor be. Get value, ref. If arguments is empty, then a let arglist be a new empty list for. Else a let arglist be. Argument list evaluation of arguments. If this constructor is false, throw a type error exception.
Can we name that? Make sure it's using pointer syntax.
6 function calls. 3, 6. 1 runtime semantics. Evaluation. Call expression. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Let expa be the call member expression that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Let member expa be the member expression of expa. Let arguments be the
Please.
evaluation of member expa.
I want to be done.
Ref is a ref.
Please let this be it.
False and ref.
This does not end.
Func percent eval percent is true. Then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. If the sort
Finally.
strict mode code, let strict caller be true. Otherwise let strict caller be false. V return. Perform eval arg. Strict caller true. Let this call be this call expression. Let tail call be as in tail position. This call return. Evaluate call. Func ref arguments. Tail call a call expression evaluation that executes step 6 AV is a direct eval. Call expression.
Leave this off and run it.
Evaluation of call
Please everything works.
value ref. Let this call be this call expression. Let tail
Please work.
this call return. Evaluate call. Func ref arguments. Tail call.
So far so good.
ECMA International 2024 1336 2 evaluate call. Func ref arguments. Tail position. The abstract operation evaluate call takes arguments func. Any CMA script language value. Ref. Any CMA script language value or a reference record. Arguments. A parse node. And tail position. A boolean. And returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref, is true, then I let this value be get this value, ref, be else. I let ref_env be ref. 2. Assert. Ref_env is an environment record. 3. Let this value be ref_env with base object. Else, I let this value be undefined. Let arglist be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return. Call. Func. This value. Arglist. 3. 7th SOP keyword. 3. 7. 1 runtime semantics. Evaluation super property. Super. Expression. Let env be get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key. Property name value. If the
Everything still works.
property is strict mode code. Let strict be true. Else let
Save back up.
return. Make super property reference.
Just off.
Property key. Strict. Super property. Super. Identifier name. Let env be get this environment. Let actual this be env get this binding. Let property key be string value of identifier name. If the source text match by the super property is strict mode code. Let strict be true. Else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super call. Super arguments. Let new target be get new target. As. RT. New target is an object. Let func be get super constructor. Let arglist be. Argument list evaluation of arguments. If this constructor, func, is false, throw a type error exception. Let result be. Construct. Func. Arglist. New target. Let the ser be get this environment. Perform the ser bind this value. Result. Let f be the ser. 0. Assert. F is an ECMA script function object. 1. Perform. Initialize instance elements. Result. F. 2. Return result. ECMA International 2024 263 1337 to get super constructor. The abstract operation get super
Let grab these as a pair.
ECMA script language value. It performs the following steps when called. Let envrec be get this environment. Assert. Envrec is a function environment record. Let active function be
I really hope this works.
ECMA script function object. Let super constructor be
Because it looks
3
like if I connect things how they are,
actual this.
it may work.
Strict. The abstract operation makes super property reference takes arguments actual this. Any CMA script language value. Property key.
There's a much higher chance
A boolean. And returns either a normal completion
that it won't.
It performs the following steps when called.
Very high chance.
Assert. Env has super binding. Is true. Let base value be env get super base. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1, 3, 3, 8, 1 runtime semantics, argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list
Go for it.
which values or an abrupt
Please work.
find piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref.
Oh man.
Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj.
I gotta like update these two, man.
Step value. Iterator record. B if next is done. Return list. C append next to list. Argument list. Argument list. Assignment expression. 1, 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return preceding args. C append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Return site obj. Template literal. Substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Let remain in B. Argument list evaluation of substitution template. Return the list concatenation of site obj and remaining. Substitution template. Template head expression template spans. Let first subref be. Evaluation of expression. Let first sub E. Get value. First subref. Let rest sub E. Substitution evaluation of template spans. Assert. Rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3, 3, 9 optional chains. 3, 3, 9. 1 runtime semantics. Evaluation. Optional expression. Member expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accessors and function calls, the first of which begins with the token ECMA International 2024-265. Optional expression. Optional expression optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. 3, 3, 9. 2 runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMA script language value, and base reference, an ECMA script language value or a reference record, and returns either a normal completion containing either an ECMA script language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R. Base value. Expression. Strict. Optional chain. Identify a name. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N. Base value. Identify a name. Strict. Optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R new value.
So we can like find and replace
Optional chain.
quicker,
The optional chain.
like a wall of things to replace past.
Value B. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true. Else let's
Getting it.
A T
Needs to be done.
R O P E R T Y capital A C C E S S capital W I T H capital I D E N new value. Identifier name strict 66 ECMA International 2024 optional chain private identifier let optional chain be option
So I won. Did all for
evaluation of option
I did all that for nothing.
reference let new value be get value new reference let field name string be the string value of private identifier return make private reference new value field name string the 3rd of March 2010 import calls 3310 1 runtime semantics evaluation import call import assignment expression let referrer be get active script or module if referrer is null set referrer to the current realm record let rgraph be evaluation of assignment expression let specify be get value rgraph let promise capability be new promise capability promise percent let's specify a string be completion to string specifier if abrupt reject promise specify a string promise capability
These two are done.
referrer specify a string empty promise
The descriptor set.
t3
And of course the descriptor set layout.
new dynamic import
I'm gonna fucking pair.
the abstract operation continue dynamic import takes arguments promise
Why is this keyboard not working?
and module completion either a normal completion containing a module record or a throw completion and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the
Chatbot said this should be defined, but it's not even present in the code.
then a perform call promise capability undefined module completion be return unused. Let module be module completion. Let load promise.
This one is
Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined reason be return unused. Let onRejected be create built-in function rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. A let link be completion module link b if link is an abrupt completion then I perform call promise capability undefined link 2. Return unused. C let evaluate promise be module evaluate. D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace. Module 2. Perform. Call. Promise capability. Undefined. Namespace 3. Return unused. E let unfulfilled be create built-in function. Fulfilled closure 0. F perform promise then. Evaluate promise.
what is this?
Return unused. Link and evaluate be create built-in function. Link and evaluate closure 0. Let perform promise then. Load promise. Link and evaluate. Unrejected. Return unused. ECMA International 2024 267.
Oh man.
And 11 tag templates. 3, 3, 1, 1, 1 runtime semantics. Evaluation. Member expression.
Descriptor set layout.
Tag ref B. Evaluation of member expression. Let tag fun be. Get value. Tag ref. Let this call be this member expression. Let tail call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. Call expression. Call expression template literal. Let tag ref be. Evaluation of call expression. Let tag func be. Get value. Tag ref. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. The 3rd of March 2012 meta properties. 3, 3, 1, 2, 1 runtime semantics. Evaluation. New target. New target 1. Return get new target. Import meter. Import meta. Let module be get active script or module. Assert. Module is a source text module record. Let import meter be module. If import meter I s empty, then a set import meter to ordinary object create. Null. B let import meter values be host get import meter properties. Module. C for each record. P of import meter values. Do. I perform. Create data property or throw. Import meter. P. D perform host finalize import meter. Import meter. Module. E set module to import meter. F return import meter. Else. A assert. Import meter is an object. B return import meter. 3, 3, 1, 2, 1. 1 host get import meter properties. Module record. The host defined abstract operation host get import meter properties takes argument module record and returns a list of records with fields. Any CMA script language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note to tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4, and the values produced by evaluating the expressions embedded within the template literal. 68, copyright sign, ECMA International 2024, 1331212, to host finalize import meter, module record. The host-defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMA script code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, unary expression yield await, 1 static semantics, early errors, update expression, left-hand side expression plus, no line terminator here, plus, no line terminator here, left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression, It is an early syntax error if assignment target type of unary expression is not simple. 3, 4, 2 postfix increment operator 1 3 4 2 1 runtime semantics, evaluation, update expression, left-hand side expression plus, let LHS be. Evaluation of left-hand side expression, let old value be. Numeric. Get value, LHS. If old value is a number, then a let new value be number. Add old value, 1. Else assert old value is a big int. Be let new value be big int. Add old value, 1z. Perfor m. Put value, LHS, new value. Return old value. ECMA International 2024 269. 1 3 4 3 postfix decrement operator 1 3 4 3 1 runtime semantics, evaluation, update expression, left-hand side expression, let LHS be. Evaluation of left-hand side expression, let old value be. Numeric. Get value, LHS. If old value is a number, then a let new value be number. Subtract old value, 1. Else assert old value is a big int. Be let new value be big int. Subtract old value, 1z. Perform. Put value, LHS, new value. Return old value, 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics, evaluation, update expression, plus unary expression, let x be. Evaluation of unary expression, let old value be. Numeric. Get value, exper. If old value is a number, then a let new value be number. Add old value, 1. Else assert old value is a big int. Be let new value be big int. Add old value, 1z. Perform. Put value, exper. New value. Return new value. 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics, evaluation, update expression, unary expression, let x be. Evaluation of unary expression, let old value be. Numeric. Get value, exper. If old value is a number, then a let new value be number. Subtract old value, 1. Else assert old value is a big int. Be let new value be big int.
Almost done. Oh my god.
Put value, exper. New value. Return new value. 70. ECMA International 2024. 13.5 Unary operators syntax. Unary expression, yield, await, update expression yield await, delete unary expression yield await, void unary expression yield await, type of unary expression yield await plus unary expression yield await, unary expression yield await, unary expression yield await, unary expression yield await, plus await expression yield, 3 5 1 the delete operator, 3 5 1 static semantics, early errors, unary expression, delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression, identifier reference, member expression, private identifier, call expression, private identifier, optional chain, private identify. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef A, B, C, D, E, F.
Only 3 years left.
Following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal.
It's missing.
Integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note to non-strict code. This syntax is legacy. 2, 9, 3, 2 static semantics. MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of
Oh man, I got one issue left. Only one.
decimal literal. It's 10e, n, where n is the number of code points in decimal digits. Excluding all occurrences.
3374.
Operator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal.
Damn it.
MV of exponent part, the MV of decimal integer literal. 0 is 0.
How does this exist?
Non-zero digit numeric literal separator.
Oh, it's right here.
The MV of non-zero digit 10n plus the MV of decimal.
Man.
Number of code points in decimal digits. Excluding all occurrences of numeric literal separator. The MV of decimal digits. Decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer.
Yes, Chatbot.
The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 28. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or of binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit. The MV of decimal digit. 6 or of non-zero digit. The MV of decimal digit. 7 or of non-zero digit. The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit. Or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4.
I want Chatbot to give me
5.
a fully working solution.
6 or of
Just like one time. If I could get one time,
7 or of octal digit.
that'd be great.
8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit. A or of hex digit. A is 10. The MV of hex digit. B or of hex digit. B is 11. The MV of hex digit. C or of hex digit. C is 12. The MV of hex digit. D or of hex digit. D is 13. The MV of hex digit. E or of hex digit. E is 14. The MV of hex digit. F or of hex digit. F is 15. The MV of binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separator binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal. Capital L E G A C.
Hopefully, this is the last thing.
Capital L I K
I just guessed that some of these had to be erased.
I M A
And I just assumed, and hopefully,
E R capital L non
I'm gonna assume my way right.
L E G A C Y capital O C
And having an image inside of this quad,
capital D
that'd be quadrific
M A
or quadtastic
N T E G E R capital L
or
MV of non-octal digit. The MV of non-octal decimal integer
quadtacular.
decimal integer literal decimal digit is the MV of
I'm all quad up.
plus the MV of decimal digit. The MV of capital L E G A C Y capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L E G A C Y, capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L, octal digit is the envy of capital L E G A C Y, capital O C T A L, capital L I K E, capital D E C I M A L, capital I N T E G E R, capital L, times 10 plus the envy of octal digit, the envy of hex digits. Hex digit is the envy of hex digit 16 plus the envy of hex digit, the envy of hex digits. Hex digits numeric literal separator hex digit is the envy of hex digit 16 plus the envy of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions: numeric literal, decimal literal, return round envy result, envy of decimal literal, numeric literal, non-decimal integer literal, return, envy of non-decimal integer literal, numeric literal, legacy octal integer literal, return, envy of legacy octal integer literal, numeric literal, colon non-decimal integer literal big int literal suffix, return a big int value for the envy of non-decimal integer literal, ECMA International 2024 229, decimal big integer literal, 0 big int literal suffix 1, return 0z, decimal big integer literal, non-zero digit big int literal suffix 1, return a big int value for the envy of non-zero digit, decimal big integer literal, non-zero digit decimal digits big int literal suffix, non-zero digit numeric literal separator decimal digits big int literal suffix, let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator, let nv be the envy of non-zero digit 10n plus the envy of decimal digits, return z, envy 2, 9, 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2 code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence, 30, ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFN RTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1. ECMA International 2024 231. Note 2, LF. MCR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2, 9, 4, 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2, 9, 4, to static semantics, SV. The syntax directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1, 2, 9, 3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028, line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029, paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028, line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029, paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take car e to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024, table 38. String single character escape sequences. Escape sequence, code unit value, Unicode character name, symbol B 0 times 0008, backspace BS T 0 times 0009, character tabulation HT N 0 times 000 line feed LF V 0 times 000B, line tabulation VT F 0 times 000C, form feed FF R 0 times 000D, carriage return CR, double quote 0 times 0022, quotation mark, apostrophe 0 times 0027, apostrophe, backslash 0 times 005C, reverse solidus, comma. The SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence, 8 is the string value consisting of the code unit 0 times 0038, digit 8. The SV of non-octal decimal escape sequence, 9 is the string value consisting of the code unit 0 times 0039, digit 9. The SV of hex escape sequence, x hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits, hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null 1 2 9 4. 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0, the MV of 0 to 3. 1 is 1, the MV of 0 to 3. 2 is 2, the MV of 0 to 3. 3 is 3, the MV of 4 to 7. 4 is 4, the MV of 4 to 7. 5 is 5, the MV of 4 to 7. 6 is 6, the MV of 4 to 7. 7 is 7, the MV of hex escape sequence, x hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits, hex digit is 0 times 1000 the MV of the first hex digit plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The P reductions below describe the syntax for a regular expression literal and are used by the input elements scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2 2 2 1 An implementation may extend the ECMA script regular expression grammar defined in 2.2.2.1, but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars, empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminated but not one of or, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, regular expression char, regular expression non-terminated but not one of or, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars, empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminator but not one of, or, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Note 1: a regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate two regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. See 2.2.2.4.34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char 2.9.5.1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1.2.9.5 to static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1.2.9.6 template literal lexical components. Syntax: template, no substitution template, template head, no substitution template, template character sop, template head, template character sop, $, template substitution tail, template middle, template tail, template middle, template character sop, $, template tail, template character sop, template characters, template character, template character sop. Note: 2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use .dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $, or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead. Not code point. Hex digits. Sep. But only if MB of hex digits. 0 times 10 FF. Code point. Hex digits. Sep. But only if MB of hex digits 0 times 10 FF. Note: template substitution tail is used by the input element template tail alternative lexical goal 1.2.9.6. 1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TB of template character and the TB of template characters. The TB of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TB of template character, $sign is the string value consisting of the code unit 0 times 0024, $sign, the TB of template character, template escape sequences the SV of template escape sequence, the TB of template character, not escape sequences undefined, the TB of template character, line terminator sequences the TRB of line terminator sequence, 236, copyright sign, ECMA International 2024, the TB of line continuation, line terminators, sequence is the empty string 1 2 9 6, to static semantics, TRB, the syntax-directed operation TRB takes no arguments and returns a string. A template literal component is interpreted by TRB as a value of the string type. TRB is used to construct the raw components of a template object, colloquially, the template raw values. TRB is similar to TV with the difference being that in TRB, escape sequences are interpreted as they appear in the literal. The TRB of no substitution template is the empty string. The TRB of template head, $sign, is the empty string. The TRB of template middle, $sign, is the empty string. The TRB of template tail is the empty string. The TRB of template characters, template characters is the string concatenation of the TRB of template character and the TRB of template characters. The TRB of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRB of template character, $sign is the string value consisting of the code unit 0 times 0024, $sign, the TRB of template character, template escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRB of template escape sequence, the TRB of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRB of not escape sequence, the TRB of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRB of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRB of decimal digit. The TRB of not escape sequence, x, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter x. The TRB of not escape sequence, x hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter x, and the TRB of hex digit. The TRB of not escape sequence, u, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter u. The TRB of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRB of hex digit. The TRB of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u. The TRB of the first hex digit, and the TRB of the second hex digit. The TRB of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u. The TRB of the first hex digit, the TRB of the second hex digit, and the TRB of the third hex digit. The TRB of not escape sequence, u, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the code unit 0 times 007b, left curly bracket. The TRB of not escape sequence, u, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRB of not code point. The TRB of not escape sequence, u, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRB of code point. The TRB of decimal digit, 1 of 0 1 2 3 4 5 6 7 8 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRB of character escape sequence, non-escape character is the SV of non-escape character. The TRB of single escape character, 1 of BF and RTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRB of hex escape sequence, x hex digit is the string concatenation of the code units 0 times 0078, Latin small letter x. The TRB of the first hex digit, and the TRB of the second hex digit. The TRB of Unicode escape sequence, u hex 4 digits is the string concatenation of the code units 0 times 0075, Latin small letter u, and the TRB of hex 4 digits. The TRB of Unicode escape sequence, u, code point, is the string concatenation of the code units 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, the TRB of ECMA International 2024 237, code point, and the code unit 0 times 007d, right curly bracket, the TRB of hex 4 digits. Hex digit is the string concatenation of the TRB of the first hex digit, the TRB of the second hex digit, the TRB of the third hex digit, and the TRB of the fourth hex digit. The TRB of hex digits. Hex hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, ABCDEF. ABCDEF is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation, line terminator sequences, the string concatenation of the code units, 0 times 005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code units 0 times 000 line feed. 2.10 automatic semicolon insertion. Most ECMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.1.0.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement 1.4.7.2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to pass the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TB excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TB and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence. 38. ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the 2 semicolons in the header of a for statement C14.7.4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression, yield, await. No line terminator here, plus left-hand side expression, yield, await. No line terminator here. Continue statement, yield, await. Continue, no line terminator here, label identifier, yield, await. Break statement, yield, await. Break, no line terminator here, label identifier, yield, await. Return statement, yield, await. Return, no line terminator here, expression, plus and yield, await. Throw statement, yield, await. Throw, no line terminator here, expression, plus and yield, await. Yield expression, in, await. Yield, no line terminator here, assignment expression in, plus yield, await. Yield, no line terminator here, assignment expression in, plus yield, await. Arrow function, in, yield, await. Arrow parameters, yield, await. No line terminator here, equals, concise body in, async function declaration, yield, await, default, async. No line terminator here, function binding identifier, yield, await. Formal parameters, yield, plus await, async function body, plus default, async. No line terminator here, function, formal parameters, yield, plus await, async function body, async function expression, async. No line terminator here, function binding identifier, yield, plus await opt. Formal parameters, yield, plus await, async function body, async method, yield, await, async. No line terminator here, class element name, yield, await. Unique formal parameters, yield, plus await, async function body, async generator declaration, yield, await, default, async. No line terminator here, function binding identifier, yield, await. Formal parameters, plus yield, plus await, async generator body, plus default, async. No line terminator here, function, formal parameters, plus yield, plus await, async generator body, async generator expression, async. No line terminator here, function binding identifier, plus yield, plus await opt. Formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async. No line terminator here, class element name, yield, await. Unique formal parameters, plus yield, plus await, async generator body, async arrow function, in, yield, await, async. No line terminator here, async arrow binding identifier, yield. No line terminator here, equals, async concise body in, capital C-O-V-E-R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, yield await. No line terminator here, equals, async concise body in, ECMA International 2024 239, async arrowhead, async. No line terminator here, arrow formal parameters, yield, plus await. The practical effect of these restricted productions is as follows. When a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a semicolon is automatically inserted before the plus plus or token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter s are followed by a line terminator before it equals token, a semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted in th. The async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is a postfix plus plus or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter s and its equals should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 210. Two examples of automatic semicolon insertion. This section is non-normative. The source 12.3 is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source 123 is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMA script sentence. The source 4A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source return a plus B is transformed by automatic semicolon insertion into the following return a plus B. The source a equals B plus plus C is transformed by automatic semicolon insertion into the following a equals B plus plus C. The source if a B else C equals D is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement. The source equals B plus C, D plus C print is not transformed by automatic semicolon insertion because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call equals B plus C, D plus C print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 210. Three interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus B is not treated as a value to be returned by the return statement because a line terminator separates it from the token return. Note 2. The token plus plus is not treated as a postfix operator applying to the variable B because a line terminator occurs between B and plus plus. ECMA International 2024 241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 210. 3. One interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator, for example if the regexp has flags. 210. 3. Two cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here in this version of ECMA script. 2, 1, 0. 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2, 42, ECMA International 2024, 13 ECMA script language, expressions, 3.1 identifier syntax, identifier reference, yield, await, identifier, yield, await, binding identifier, held, await, identifier, yield, await, label identifier, yield, await, identifier, yield, await, identifier name but not reserved word, 3, 1, 1 static semantics, early errors, binding identifier, it is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval, identifier reference, yield binding identifier, yield label identifier, yield, it is a syntax error if the source text matched by this production is contained in strict mode code, identifier reference, await binding identifier, await label identifier, await, it is a syntax error if the goal symbol of the syntactic grammar is module, binding identifier, yield, await, yield, it is a syntax error if this production has a yield parameter, binding identifier, yield, await, ECMA International 2024 243, yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, comma it is a syntax error if this production has an await parameter, identifier reference, yield, await, identifier binding identifier, yield, await, identifier label identifier, yield, await, identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3, 1, 2 static semantics, string value. The syntax directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier part. Let id text unescape the identifier code points of identifier name, return code points to string, id text unescaped, identifier reference, yield binding identifier, yield label identifier, yield, return yield, identifier reference, await binding identifier, await label identifier, await, return await, identifier name but not reserved word, return a string value of identifier name, private identifier name, return the string concatenation of 0 times 0023, number sign, and the string value of identifier name, module export name, string literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode ESCA. Pay sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024. 131. 3 runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression. Yield. Await. This. Identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield, await, expression, plus and yield await, expression, plus and yield await, dot, binding identifier yield await, dot, binding pattern yield await, expression, plus and yield await, binding identifier yield await, expression, plus and yield await, binding pattern yield await. Note 2 in non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024 245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N capital A N yield await. The interpretation of capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N is refined using the following grammar. Parenthesized expression yield await expression class and yield await 3 2 1 at this keyword 3 2 1 1 runtime semantics evaluation primary expression this return resolve this binding 3 2 2 identifier reference C13.1 for identifier reference 1 3 2 3 literals syntax literal null literal boolean literal numeric literal string literal 3 2 3 1 runtime semantics evaluation literal null literal 1 return null literal boolean literal if boolean literal is the token false return false if boolean literal is the token true return true literal numeric literal return the numeric value of numeric literal as defined in 1 2 9 3 literal string literal return the sv of string literal as defined in 1 2 9 4 2 46 ECMA International 2024 1 3 2 4 array initializer array elements may be elided at the beginning middle or end of the element list whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax, array literal, yield, await, elision ort, element list yield await, element list yield await, elision ort, element list, yield, await, elision ort assignment expression, class and yield await, elision ort spread element yield await, element list yield await, elision ort assignment expression, class and yield await, element list yield await, elision ort spread element yield await, elision, spread element, yield, await, dot, assignment expression, class and yield await, 1 3 2 4 1 runtime semantics, array accumulation. The syntax directed operation array accumulation takes arguments array, a next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision, let len be next index plus 1. Perform. Set, array, length, len, true, note, the above step throws if len exceeds 232 1. Return len, elision, return. Array accumulation of elision with arguments array and next index plus 1. Element list, elision ort assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value, init result. Perform. Create data property or throw, array, to string, next int x, init value, return next index plus 1. Note an array literal is an expression describing the initialization of an array, using a list of 0 or more expressions each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list, elision ort spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list, elision ort assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value, init result. Perform. Create data property or throw, array, to string, next int x, init value, return next index plus 1. Element list, elision ort spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return next index. See perform. Create data property or throw, array, to string, next int x, next, d set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision ort. Let array be. Array create. 0. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. Let array be. Array create. 0. Perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision ort. 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. 3. If elision is present, then a perform. Array accumulation of illusion with arguments array and next index. Return array. 3, 2, 5 object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Class in yield await. Method definition yield await. Dot. Assignment expression, class in yield await, property name, yield, await, literal property name, computed property name yield await, literal property name, identifier name, string literal numeric literal, computed property name, yield, await, assignment expression, class in yield await, cover initialized name, yield, await, identifier reference yield await, initializer, class in yield await, initializer, in, yield, await, assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign, ECMA International 2024 249. Note 3 in certain contexts. Object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics, early errors, property definition, method definition, bullet. It is a syntax error if his direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In, used as a cover grammar for object assignment pattern and may be recognized as part of a capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, or capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5.
I told Chatbot
Operation is computed properly.
this was missing.
It is defined piecewise over the following productions. Property name.
Like first.
Property name. Computed property name. Return true.
And Chatbot told me, but I want to hear.
There also 200.
I fell for it again. I fell for it again.
This production exists.
I said yes. Do that.
Object assigned.
And I wasted time. Not really though. I can like refactor it with other stuff.
Using a computed property name.
Just piece it together as I go.
3 statics of
Almost there.
list. This
All I need are all the pieces.
takes no
Almost have them all. It's right here.
over the following productions. Property definition list. Property definition
I said, why don't I have descriptor set? What's needed? Is that on an it?
list.
Or initialize the stuff.
Property name list of property definition.
And then yada yada yada.
If prop name is empty, return list. Return the list concatenation of list and
Eventually it said that you need like multiples of it, like an array.
object literal. Return
Because
percent object prototype percent object literal
it broke it down
property definition list.
to this table to make it really clear what's going on.
Evaluation.
As you can see how clear this table is. This is a very clear table.
Return string value of identify name. Literal property name. String literal 1.
It's like after reading this table,
Literal property.
it's like
BRB the new
without a doubt,
return to
I understand everything. Yes, totally.
let x per value be equation of assignment
It says what you should do, blah blah blah.
the value return to property key property
You have one texture per frame.
5 runtime semantics
You need one descriptor set per frame,
restricted operation property
each pointing to that frame's view.
an object and returns either a normal
A single sampler,
completion
a single descriptor layout, blah blah blah.
property definition list Property definition list. Property definition.
I need to look up what max frames of flight is.
Object. Perform. Property definition. Evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition.
I have a loop on startup.
B. Evaluation of assignment expression. Let from value B. Get value. X per value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value.
And it happens right here in the startup chain.
Identifier reference. Let prop name be string value of identifier reference. Let X per value be. Evaluation of identifier reference. Let prop value be. Get value. X per value.
So it's after the stuff above. So it looked like it was okay to attach stuff here.
Or throw.
Like everything's like already attached. It's not like
Property name.
something's in incomplete state. It's like everything above is settled.
The script that is being evaluated.
This is a good point to like insert the stuff that I need.
Let is proto set to be false.
Because it's a video card. It's magic. Triangle land.
Then in
It doesn't have to make sense.
is proto set to be.
It just has to follow the predefined set of function calls.
Then in let prop value.
And it'll work.
Of assignment expression with argument prop key. Else a let X per value of B. Evaluation of assignment expression. Be let prop value B.
Alright, so this is what was missing here, right?
Letter is true.
Or I don't know why I said right. This is literally what was missing.
Correct. Prop value B.
So I go up. Like, up to next word, whatever. Control F, find.
Data property.
Then up to next one, next
0.
to here.
Property definition. Method definition.
And then the one thing that's missing
With argument.
now
Return unused. 3.
is this.
Defining expressions. See 15.2 for primary expression.
Do you notice how it's the word descriptor set, but with an S?
15.8
There's just one more letter on it.
for
So chatbot fixed my problem by giving me a new problem.
generator expression. 52. Copyright sub.
So it didn't fix anything, it just reorganized stuff.
7. Regular
I think it did actually add a couple attributes or things to the tables,
early.
but I could have figured that out. That wasn't really helpful.
It is a syntax error.
What would have been helpful
Capital
is if it gave me the fucking solution
R E
for exactly what I asked for, not just every single thing around what I asked for.
E S
Because now this is still missing,
O N
and chatbot decided to name it with an S.
A. Regular expression literal is false.
It's the same thing that's missing, so it didn't.
Capital V
It's pointless.
I D
So annoying.
G
I'm literally almost done.
R capital E X P R E S S R
And this thing is not even defined.
I T
I'm scrolling up and down to find the next. There's nothing before it or after it.
E G U L A R capital R E F
There's nothing.
R A takes argument literal.
This is one match because there's only one in the file.
It determines if its argument is a valid regular expression literal. It performs the flag text of literal. If flags contain
So chatbot didn't help at all,
M
and then it made the same exact issue in the same exact way
once
for the same exact holy camole.
V let V be true. Else let
This is frustrating.
is false and V is false. Then a let string value be code points to string pattern text. B set pattern text to the sequence of
So I'm gonna ask chatbot,
the 16-bit elements of string value as a unit.
why is descriptor sets missing?
Apply to the elements. Let parse.
Because I just need this to be done.
If parse result
Oh, but I told it to do this in here
3
because this is where it loops through
semantics
however many
expression regular
frames are.
B code points to string body text of regular expression literal. Let flags be code points to string flag text of regular expression lit
I think it's this one. Swap count.
pattern flags 3 2 8 template literal syntax template literal yield await tagged no substitution template yield await tagged substitution template yield await tagged template head expression plus and yield await template spans yield await tagged template spans yield await tagged template tail template middle list yield await
I'd like to get this number.
International 2024 253 template middle list yield await tagged
Right here.
expression plus and
Possibly.
list yield await tagged template middle expression plus
So I'm gonna check if
8 1 stack
max frames of flight is equal to this number.
await tagged no substitution template. It is a syntax error there. Tagged parameter was not set and no substitution template contains not escape sequence template literal yield await tagged Substitution template yield a weight tag. It is a syntax error if the number of elements in the result is
So it was here. So go forward again.
greater than or equal to 232. Substitution
Paste is here.
tagged. Template head express.
What the heck?
Template spans yield a weight tag. It is a syntax error if the
Something's wrong with this clipboard.
not escape sequence. Template
It's really annoying.
template tail. It is a syntax error if the
And the scroll wheel.
tail contains not escape sequence.
I'll scroll and I'll start flipping desktops.
Tagged. Template middle.
And I'll paste and I'll pull something out of nowhere.
Template middle. Expression. Club.
That was like 5 pastes ago. I just paste this random crap.
Not escape sequence.
It's not random. It's just really old, stale. Why is it even the clipboard?
Operation template strings takes argument draw, a boolean, and return.
Something's like out of sync on this computer.
Doing productions. Template literal. No substitution template. Return template string. No substitution template. Raw. Substitution template. Template head expression template spans. Let head be template string. Template head. Raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans. Template tail. Return template string. Template
Alright, so we'll print these two.
spans. Template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string. Template tail. Raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list. Template middle expression 1. Return template string. Template middle. Raw. Template middle list. Template middle list. Template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string. Template middle. Raw. Return the list concatenation of front and last. 3, 2, 8. 3 static semantics. Template string. Template token. Raw. The abstract operation template string takes arguments template token. A no substitution template parse node. A template head parse node. A template middle parse node. Or a template tail parse node. And raw. A boolean. And returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the trv of template token, else a let string be the tv of template token, return string. 3, 2, 8. 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do I fe is the same parse node as template literal. Then I return e. Let raw strings be template strings of template literal with argument true. Assert raw string
Whatever this one is.
strings be template strings of template
Swap chain, image count.
be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0 2. Repeat while index count a let prop be to string index be let cooked value be cooked strings index c perform define property or throw template prop property descriptor cooked value writable false true false let raw value be the string value raw strings index e perform define property or throw raw obj prop property descriptor raw value false true false f set index plus 1 3 perform set integrity level raw obj frozen 4 perform define property or throw template raw property descriptor raw obj false enumerable false false 5 perform set integrity level template frozen 6 append the record template literal template to realm 7 return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMA script code. 1 3 2 8 5 Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let preceding be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return. The list concatenation of preceding and next. 3 2 8 6 Runtime semantics. Evaluation. Template literal. No substitution template. Return the TB of no substitution template as defined in 1 2 9 6. Substitution template. Template head expression. Template spans. Let head be the TB of template head as defined in 1 2 9 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return a string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3 future editions of this specification may define additional non-enumerable properties of template objects. Note 1 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TB of template tail as defined in 1, 2, 9, 6. Template spans. Template middle list template tail. Let it be. Evaluation of template middle list. Let tail be the TB of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TB of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TB of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return the string concatenation of rest, middle, and last. 3, 2, 9 the grouping operator. 3, 2, 9. 1 static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. To runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return. Evaluation of expa parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257. 13.3 left-hand side expression syntax. Member expression, yield, await. Primary expression yield await. Expression yield await. Expression, plus and yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged. Super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier. Super property. Yield await. Super expression plus and yield await. Super. Identifier name, meter property, new target, import meter new target, new target, import meter, import meta, new expression, yield, await, member expression yield await, new expression yield await, call expression, yield, await, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression, plus and yield await, call expression yield await. Identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await. Private identifier, super call, yield, await, super arguments yield await, import call, yield, await, import, assignment expression, plus and yield await, arguments, yield, await, argument list yield await, argument list yield await. 58. ECMA International 2024. Argument list, yield, await, assignment expression, plus and yield await. Dot. Assignment expression, plus and yield await. Argument list yield await. Assignment expression, plus and yield await. Argument list yield await. Assignment expression, plus and yield await. Optional expression, yield, await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain, yield, await. Arguments yield await. Expression, plus and yield await. Identifier name, template literal yield await, plus tagged. Private identifier, optional chain yield await. Arguments yield await. Optional chain yield await. Expression, plus and yield await. Optional chain yield await.
hate everything. I freaking hate everything.
Optional chain yield await. Private identifier.
Fuck.
Expression yield.
Oh my god.
Call expression yield await. Optional expression yield await. Supplemental syntax. When processing an instance of the production, call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. The interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is refined using the following grammar. Call member expression yield await. Member expression yield await. Arguments yield await. 3 3 1 static semantics. 3 3 1 1 static semantics. Early errors. Optional chain template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. Eck, Mar International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A, B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meta. It is a syntax error if the syntactic goal symbol is not module 1.3.3 to property accessors. Note properties are accessed by name using either the dot notation. Member expression. Identify name call expression.
Why is this not building?
Member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression. Identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression. Identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3.
Oh, I forget to put the defines.
Evaluation, member
Value.
expression, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T
Okay, I think this works.
E C E S S capital W I T H
What the hell was I doing?
P
Fucking hate this.
expression strict 60. Expression, member expression, identify name.
There's a print, the two
Let base value be. Get value
in flight, and the value that's pulled from the call.
be true, else let strict be false.
That was it.
Capital E V A L U
Man,
E capital P R O P E R T
this is not a real define.
C E S S capital
I didn't even paste it in.
T H capital I D E N base value identifier name strict member expression private identifier let base reference
This isn't even declared.
member expression let base value be get value base reference
So I'm not gonna bother using it.
return make private reference base value field
It's a waste of time, man. I hate chatbot.
let base value be get value base reference if
So it's 2. Thank you, chatbot. Damn it.
strict be false return
I gotta get the freaking command line.
A L U A T E
Chatbot's like, oh, use max frames in flight. Fucking doesn't exist.
A C C E S
Holy camole. That's my new thing.
E X P R base value expression strict call expression call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false return capital E V A L U A T E
So I have a loop. Everything is nice, neat, and tidy. It should run.
C C
But I'm missing whatever the stupid thing is.
W I T H capital I D E N base value identifier name strict call expression call
I would like to just drop chatbot,
expression let
but I'm so close.
field
I don't want to, like, if I have to look for documentation, it's gonna take me like days
capital
to catch up to where I would be
L
in finding stuff.
E E
So I don't have time to do that. I'm stuck with chatbot.
E R T Y C E S S capital W I T H capital E X P R base value expression strict. The abstract operation capital E V A L U A T E capital
Alright, so my chatbot.
P E R
Why is it missing? Save it back up.
C C E S S capital W I T H capital E X P R takes argument space value, an ECMA script language value, expression, an expression parse node, and strict.
It's still literally missing the one thing that was missing in the first place.
It performs the following
So stupid.
evaluation of expression. Let property name value be. Get value, property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3, 3, 4, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T,
Why is it chatbot?
I, D.
Why is the scripter sets, like, still not assigned?
The abstract
You didn't even declare it for use.
A, L, U, A,
What even?
P, R, O, E, R,
I say, would your mother be proud of this?
T, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes argument space value, an ECMA script language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record.
Oh, it's like the same thing.
Property names,
But it's mom.
identify name, return the reference record, base value, property name string, strict, empty, ECMA International 2024 261, 133, 5 venue operator, 3,
Assuming using,
runtime 6,
assuming got me to this point. So get me further. Come on.
evaluate,
Just assume me to get done with this.
for expression arguments 1, return,
Assuming using one descriptor set per swap chain image.
construct expa, arguments, the abstract operation evaluate new takes,
I assumed this would be something like
expression parse node,
x86 or ARM assembly, but it's not. This is a joke. It's terrible.
value or an abrupt completion,
It's not. It's nothing. It's crap.
expa, let constructor be, get value, ref, if
Which matches your use case
a let arglist be,
before the for loop.
evaluation of arguments, if this construct, for exception, return, construct, constructor, arglist, 3, 3, 6 function calls, 3, 3, 6, 1 runtime semantics, evaluation, call expression, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R,
Oh my god.
O, N, capital A, N,
I need this descriptor pool.
S, Y, N,
Does this end?
A, R,
Seriously. Fuck.
that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R.
Oh my god.
Arguments be the arguments of expa. Let ref be. Evaluation of member expa. Let func be. Get value. Ref. If ref is a reference record, is property. Efference. Ref is false. Same value.
How many?
Ent is
How much? Ooh.
argument list evaluation of argument.
Why does it take so much
Turn undefined.
to get a simple thing
If the source text
on a quad?
code, let strict caller be true.
This is, it's quadriculous.
Eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position. This call, return. Evaluate call, func, ref, arguments. Tail call, a call expression evaluation that executes step 6 AV is a direct eval. Call expression,
Do I have this?
let ref be. Evaluation of call expression, let func be. Get value, ref. Let this call be this call expression. Let
Of course I do. It's right here.
this call, return. Evaluate call,
I commented it out because it wasn't working.
tail call, 62. ECMA International 2024. 13336. 2 evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func. An ECMA script language value. Ref. An ECMA script language value or a reference record. Arguments. A parse node. And tail position. A boolean. And returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref, is true, then I let this value be get this value, ref, be else. I let ref env be ref. 2. Assert. Ref env is an environment record. 3. Let this value be ref env with base object, else, let this value be undefined. Let arglist be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return. Call. Func. This value. Arglist. 3, 3, 7 specify keyword. 3, 3, 7, 1 runtime semantics. Evaluation super property. Super. Expression. Let env get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key, property name value. If the source text match by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference.
Oh, this is so annoying.
Strict, super property, super. Identify a name. Let env get this environment. Let actual this be env get this binding. Let property key be string value of identify name. If the source text match by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super cool. Super arguments. Let new target be get new target. As. RT. New target is an object. Let func be get super constructor. Let arglist be. Argument list evaluation of arguments. If this constructor, func, is false, throw a type error exception. Let result be. Construct. Func. Arglist. New target. Let the ser be get this environment. Perform the ser binds this value. Result. Let f be the ser. 0. Assert. F is an ECMA script function object. 1. Perform. Initialize instance elements. Result. F2. Return result. ECMA International 2024 263 1337 to get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMA script language value. It performs the following steps when called. Let envrec be get this environment. Assert. Envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMA script function object. Let super constructor be active function. Return super constructor. 3, 3, 7, 3 make super property reference. Actual this. Property key. Strict. The abstract operation makes super property reference takes arguments actual this. An ECMA script language value. Property key. A property key. And strict. A boolean. And returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env get this environment. Assert. Env has super binding. Is true. Let base value be env get super base. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3, 3, 8 argument lists. Note the evaluation of an argument list produces a list of values 1, 3, 3, 8, 1 runtime semantics. Argument list evaluation. The syntax directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return list. See append next to list. Argument list. Argument list. Assignment expression. 1, 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return preceding args. See append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Return site obj. Template literal. Substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Let remain in be. Argument list evaluation of substitution template. Return the list concatenation of site obj and remaining. Substitution template. Template head expression template spans. Let first subref be. Evaluation of expression. Let first sub be. Get value. First subref. Let rest sub be. Substitution evaluation of template spans. Assert. Rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3, 3, 9 optional chains. 3, 3, 9, 1 runtime semantics. Evaluation. Optional expression. Member expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accessors and function calls, the first of which begins with the token ECMA International 2024 265. Optional expression. Optional expression optional chain. Let base reference be. Evaluation of optional expression. Let base value be get value, base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. 3.3.9. To runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, any CMA script language value, and base reference, any CMA script language value or a reference record, and returns either a normal completion containing either an ECMA script language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text match by this optional chain is strict mode code, let strict be TRUE, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R. Base value. Expression. Strict. Optional chain. Identify a name. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N. Base value. Identify a name. Strict. Optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R. New value. Expression. Strict. Optional chain. Optional chain. Identify a name. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N. New value. Identify a name. Strict. 66. ECMA International 2024. Optional chain. Optional chain. Private identifier. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let field name string be the string value of private identifier. Return make private reference. New value. Field name string. The 3rd of March 2010 import calls. 3.3.1.0. 1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let argraph be. Evaluation of assignment expression. Let specify be. Get value. Argraph. Let promise capability be. New promise capability. Promise %. Let specify a string be completion. To string. Specifier. If abrupt reject promise. Specify a string. Promise capability. Perform host load imported module. Referrer. Specify a string. Empty. Promise capability. Return promise capability. 3.3.1.0.1. 1 continue dynamic import. Promise capability. Module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise kappa, ILT record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call, promise capability, undefined, reason B return unused, let onRejected be create built-in function, rejected closure, 1, let link and evaluate closure be a new abstract closure with no parameters that captures module, promise capability, and onRejected and performs the following steps when called, a let link be completion, module link, B if link is an abrupt completion, then I perform, call, promise capability, undefined, link, 2, return unused, C let evaluate promise be module evaluate, D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called, I let namespace be get module namespace, module 2, perform, call, promise capability, undefined, namespace, 3, return unused, E let unfulfilled be create built-in function, fulfilled closure, 0, F perform promise then, evaluate promise, unfulfilled, onRejected, G return unused, link and evaluate be create built-in function, link and evaluate closure, 0, let perform promise then, load promise, link and evaluate, onRejected, return unused, ECMA International 2024 267, the 13th of March 2011 tag templates, 3.3.1.1, 1 runtime semantics, evaluation, member expression template literal, let tag ref be, evaluation of member expression, let tag fund be, get value, tag ref, let this call be this member expression, let tail call be as in tail position, this call, return, evaluate call, tag func, tag ref, template literal, tail call expression template literal, let tag ref be, evaluation of call expression, let tag fund be, get value, tag ref, let this call be this call expression, let tail call be as in tail position, this call, return, evaluate call, tag func, tag ref, template literal, tail call, the 3rd of March 2012 meta properties, 3.3.1.2, 1 runtime semantics, evaluation, new target 1, return get new target, import meter, import meta, let module be get active script or module, assert, module is a source text module record, let import meter be module, if import meter I, s empty, then A set import meter to ordinary object create, null, B let import meter values be host get import meter properties, module, C for each record, P of import meter values, do, I perform, create data property or throw, import meter, P, D perform host finalize import meter, module, E set module to import meter, F return import meter, else, A assert, import meter is an object, B return import meter, 3.3.1.2.1, 1 host get import meter properties, module record, the host defined abstract operation host get import meter properties takes argument module record, and returns a list of records with fields, any CMA script language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4, and the values produced by evaluating the expressions embedded within the template literal 68. Copyright sign ECMA International 2024 133.1.2.1 to host finalize import meter, module record. The host defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties, and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMA script code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, 1 3 4 1 static semantics, early errors, update expression, left-hand side expression plus, no line terminator here, plus, no line terminator here, left-hand side expression, it is an early syntax error if assignment target type of left-hand side expression is not simple, update expression plus unary expression, it is an early syntax error if assignment target type of unary expression is not simple, 3 4 2 postfix increment operator 1 3 4 2 1 runtime semantics, evaluation, update expression, left-hand side expression plus, let LHS be, evaluation of left-hand side expression, let old value be, numeric, get value, LHS, if old value is a number, then a let new value be number, add, old value, 1, else, assert, old value is a bigint, be let new value be bigint, add, old value, 1z, perfor, m, put value, LHS, new value, return old value, ECMA International 2024 269, 1 3 4 3 postfix decrement operator 1 3 4 3 1 runtime semantics, evaluation, update expression, left-hand side expression, let LHS be, evaluation of left-hand side expression, let old value be, numeric, get value, LHS, if old value is a number, then a let new value be number, subtract, old value, 1, else, assert, old value is a bigint, be let new value be bigint, subtract, old value, 1z, perform, put value, LHS, new value, return old value, 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics, evaluation, update expression, plus unary expression, let x be, evaluation of unary expression, let old value be, numeric, Get value, expr, if old value is a number, then a let new value be number, add, old value, 1, else, assert, old value is a big int, be let new value be big int, add, old value, 1z, perform, put value, expr, new value, return new value, 3, 4, 5 prefix decrement operator 1, 3, 4, 5, 1 runtime semantics, evaluation, update expression, unary expression, let expr be, evaluation of unary expression, let old value be, denumeric, get value, expr, if old value is a number, then a let new value be number, subtract, old value, 1, else, assert, old value is a big int, be let new value be big int, subtract, old value, 1z, perform, put value, expr, new value, return new value, 70, ECMA International 2024, 13.5 unary operators syntax, unary expression, yield, await, update expression yield await, delete unary expression yield await, void unary expression yield await, type of unary expression yield await plus unary expression yield await, unary expression yield await, unary expression yield await, unary expression yield await plus await, await expression yield, 3, 5, 1 the delete operator, 3, 5, 1, 1 static semantics, early errors, unary expression, delete unary expression, it is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression, identifier reference, member expression, private identifier, call expression, private identifier, optional chain, private identity.
This was being set up a different way. Like you can like set it to the swap chain, then swap it in or something for texture. And chatbot said, well, you could do it this way too. And I fell for it. I should have just if I can get these last couple functions, I'm good. That's literally all there is to it. There's only a couple left that could possibly be called. I've seen them before, so I know this has to be it. I can't get to the stupid program to do the standard until this is done. Everything's literally waiting on this stupid shader program. Oh, this is annoying. And I want to use the video, this video, not the image. This is a crappy image. I want what I want. It'll look cool, so I want the video. That's all I want. I don't want to use like a random ass TV. I want to use something I did. Because I can't. It's like I have to set it up. I already have it all planned out. So I want to do it and get it over with. At first I didn't care, but now it's like, you know what? I might as well use my assets and stuff, resources for it. Make it fancy. Oh, I gotta get this done. This would ran without errors. And there's no desktop on that surface. Nothing at all. Where the fuck is the desktop? So I gotta investigate. Oh, this is getting so old. Oh wait, it's not calling it. Wait, there's hope. There's hope. Or not, I don't know. Nope, there's no hope at all. Are you kidding me? Is it still missing the one thing that's been missing the whole fucking... I bit my tongue. Fuck. I'm gonna stop complaining. Oh my god, my tongue. I think it's bleeding. Oh, I'm kind of annoyed. I'm just listening to really loud music.
array literal, return true, return false. If primary expression is either an object literal or an array literal, return true, return false. Member expression, member expression, expression, member expression. Identify name member expression template literal super property, meter property, new member expression arguments member expression. Private identifier, new expression, left hand side expression, call expression, optional expression, return false. For declaration, let or const for binding, return is destructuring of for binding. For binding, binding identifier, return false. 06, ECMA International 2024. For binding, binding pattern 1. Return true. Note this section is extended by an XB. 3.5, 4, 7, 5, 3 runtime semantics. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, I, T, I, A, L, I, Z. The syntax directed operation. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, I, T, I, A, L, I, Z, takes arguments value, any CMA script language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. For declaration, let or const for binding, return. Binding initialization of for binding with arguments value and environment. 4, 7, 5, 4 runtime semantics. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A. The syntax directed operation. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, takes argument environment to declarative environment record, and returns unused. It is defined piecewise over the following productions. For declaration, let or const for binding. For each element name of the bound names if for binding, do A if this constant declaration of let or const is true. Then, I perform environment create immutable binding. Name, true B else, I perform environment create mutable binding. Name, false 2. Return unused. 4, 7, 5 runtime semantics. For an of loop evaluation, the syntax directed operation for an of loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. For an of statement, 4, left-hand side expression in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, left-hand side expression, statement, key result, enumerate, assignment, label set. For an of statement, 4, var for binding in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, for binding, statement, key result, enumerate, var binding, label set. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements in the formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 307. For an of statement, 4, for declaration in expression statement, let key result be. For an of head evaluation, bound names of for declaration, expression, enumerate, return. For an of body evaluation, for declaration, statement, key result, enumerate, lexical binding, label set. For an of statement, 4, left-hand side expression of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set. For an of statement, 4, var for binding of assignment expression statement, let key result be. For an of head evaluation, assignment expression, iterate, return. For an of body evaluation, for binding, statement, key result, iterate, var binding, label set. For an of statement, 4, for declaration of assignment expression statement, let key result be. For an of head evaluation, bound names of for declaration, assignment expression, iterate, return. For an of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set. For an of statement, for await, left-hand side expression of assignment expression statement, let key result be. For an of head evaluation, assignment expression, async iterate, return. For an of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set, async. For an of statement, for await, var for binding of assignment expression statement, let key result be. For an of head evaluation, assignment expression, async iterate, return. For an of body evaluation, for binding, statement, key result, iterate, var binding, label set, async. For an of statement, for await, for declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, async iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, async. Note this section is extended by an XB. 3.5, 4, 7, 5, 6 for in of head evaluation, uninitialized bound names, expr, iteration kind. The abstract operation for in of head evaluation takes arguments uninitialized bound names, a list of strings, expr, an expression parse node or an assignment expression parse node, and iteration kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let all dnv be the running execution context's lexical environment. If uninitialized bound names is not empty, then 08. ECMA International 2024 ABC D. Assert. Uninitialized bound names has no duplicate entries. Let new env be new declarative environment. Old env for each string name of uninitialized bound names. Do. I perform new env create mutable binding. Name. False. Set the running execution context's lexical environment to new env. 3. Let expr f be completion. Evaluation of expr. Set the running execution context's lexical environment to old env. Let expr value be. Get value expr f. If iteration kind is enumerate, then if expr value is either undefined or null, then I return completion record, break, empty, empty, b let obj be. To object, expr value, c let iterator be enumerate object properties, obj d let next method be. Jet, iterator, next, e return the iterator record, iterator, next method, false, else, assert, iteration kind is either iterate or async iterate, b if iteration kind is async iterate, let iterator kind be async, c else, let iterator kind be sync, d return. Get iterator, expr value, iterator kind. The abstract operation for in of body evaluation takes arguments LHS, a parse node, STMT, a statement parse node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If iterator kind is not present, set iterator kind to sync. Let all dnv be the running execution context's lexical environment. Let v be undefined. Let destructuring be as destructuring of LHS. If destructuring is true and LHS kind is assignment, then assert. LHS is a left-hand side expression. B let assignment pattern be the assignment pattern that is covered by LHS. Repeat. A let next result be. Call. Iterator record. Iterator record. B if iterator kind is async. Set next result 2. Await. Next result. See if next result is not an object. Throw a type error exception. DLS done B. Iterator complete. Next result. E if done is true. Return V. F let next value be. Iterator value. Next result. G if LHS kind is either assignment or var binding. Then I if destructuring is true. Then if LHS kind is assignment. Then a let status be completion. Destructuring assignment evaluation of assignment pattern with argument next value 2. Else. Assert. LHS kind is var binding. B assert. LHS is a for binding. C let status be completion. Binding initialization of LHS with arguments next value and undefined. 2. Else. Let LHS ref be completion. Evaluation of LHS. It may be evaluated repeatedly. If LHS ref is an abrupt completion, then a let status be LHS ref 3. Else. A let status be completion. Put value. LHS ref. Next value. 8 else. I assert. LHS kind is lexical binding. 2. Assert. LHS is a for declaration. 3. Let iteration env be new declarative environment. Old env. I've. Perform. Capital F. O. R. Capital D. E. C. L. A. R. A. T. I. O. N. Capital B. I. N. D. I. N. G. Capital I. N. S. T. A. N. T. I. A. Of LHS with argument iteration en V. For in of body evaluation, LHS, STMT, iterator record, iteration kind, LHS kind, label set, iterator kind. 7. ECMA International 2024 309. 14. 7. 5. 8. Runtime semantics. Evaluation. V set the running execution context lexical environment to iteration env. V. If destructuring is true, then let status be completion. For declaration binding initialization of LHS with arguments next value and iteration env. 7. Else. Assert. LHS binds a single name. Let LHS name be the sole element of bound names of LHS. Let LHS ref be. Resolve binding. LHS name. Let status be completion. Initialize reference binding. LHS ref. Next value. I if status is an abrupt completion, then I set the running execution context's lexical environment to old env. 2. If iterator kind is async, return. Async iterator close. Iterator record. Status. 3. If iteration kind is enumerate, then return status sive. Else. Assert. Iteration kind is iterate. Return. Iterator close. Iterator record. Status. J let result be completion. Evaluation of STMT. K set the running execution context's lexical environment to old env. L if loop continues. Result. Label set. Is false. Then I if iteration kind is enumerate. Then 1. Return. Update empty. Result. V. 2. Else. Assert. Iteration kind is iterate. Set status to completion. Update empty. Result. V. If iterator kind is async. Return. Async iterator close. Iterator record. Status. Return. Iterator close. Iterator record. status, m if result is not empty, set v to result, binding identifier, yield await, let binding id string value of binding identifier, return, resolve binding, binding id, 4, 7, 5, 9, enumerate object properties. O, the abstract operation enumerate object properties takes argument O, an object, and returns an iterator. It performs the following steps when called. Return an iterator object, 27112, whose next method iterates over all the string valued keys of enumerable properties of the iterator object is never directly accessible to ECMA script code. The mechanics and order of enumerating the properties is not specified but must conform to the rules specified below. The iterator's throw and return methods are null and are never invoked. The iterator's next method processes object properties to determine whether the property key should be returned as an iterator value. Returned property keys do not include keys that are symbols. Properties of the target object may be deleted during enumeration. A property that is deleted before it is processed by the iterator's next method is ignored. If new properties are added to the target object during enumeration, the newly added properties are not guaranteed to be processed in the active enumeration. A property name will be returned by the iterator's next method at most once in any enumeration. Enumerating the properties of the target object includes enumerating properties of its prototype, and the prototype of the prototype, and so on, recursively. But a property of a prototype is not processed if it has same 10, copyright sign, ECMA International 2024. Name is a property that has already been processed by the iterator's next method. The values of attributes are not considered when determining if a property of a prototype object has already been processed. The enumerable property names of prototype objects must be obtained by invoking enumerate object properties passing the prototype object as the argument. Enumerate object properties must obtain the own property keys of the target object by calling its internal method. Property attributes of the target object must be obtained by calling its internal method. In addition, if neither row nor any object in its prototype chain is a proxy exotic object, typed array, module namespace exotic object, or implementation provided exotic object, then the iterator must behave as with the iterator given by create for an iterator, O until one of the following occurs. The value of the internal slot of O or an object in its prototype chain changes. A property is removed from O or an object in its prototype chain. A property is added to an object in O's prototype chain, or the value of the attribute of a property of O or an object in its prototype chain changes. Note 1. ECMA script implementations are not required to implement the algorithm in 1 directly. They may choose any implementation whose behavior will not deviate from that algorithm unless one of the constraints in the previous paragraph is violated. The following is an informative definition of an ECMA script generator function that conforms to these rules. Function enumerate object properties. obj const visited equals new set. 4. Const key of reflect own keys. obj if type of key equals symbol. Continue. Const desk equals reflect get own property descriptor. obj key if desk visited add key if desk enumerable yield key. Const proto equals reflect get prototype of obj if proto equals null. Return 4. Const proto key of enumerate object properties. Prota if visited has proto key yield proto key. Note to the list of exotic objects for which implementations are not required to match create for an iterator was chosen because implementations historically differed in behavior for those cases, and agreed in all the others. 4, 7, 5, 1, 0 for an iterator objects. For an iterator is an object that represents a specific iteration over some specific object. For an iterator objects are never directly accessible to ECMA script code. They exist solely to illustrate the behavior of enumerate object properties. ECMA International 2024 311 1 create for an iterator object. The abstract operation create for an iterator takes argument object, and returns a for an iterator. It is used to create a for an iterator object which iterates over the own and inherited enumerable string properties of obj in a specific order. It performs the following steps when called. Let iterator be ordinary object create, % for an iterator prototype %, set iterator to object, set iterator to false, set iterator to a new empty list, set iterator to a new empty list, return iterator, 4, 7, 5, 1, 0, to the % for an iterator prototype %object. The % for an iterator prototype %object has properties that are inherited by all for an iterator objects, is an ordinary object, has an internal slot whose value is % iterator prototype %, is never directly accessible to ECMA script code, has the following properties, 4, 7, 5, 1, 0, 2, 1% for an iterator prototype %. Next, let O be this value, assert, O is an object, assert, O has all of the internal slots of a for an iterator instance, 1, 4, 7, 5, 1, 0, 3. Let object be O, repeat, if O is false, then I let keys be object, 2. For each element key of keys, do, if key is a string, then A append key to O 3. Set O to true, B repeat. While O is not empty, I let R be the first element of O. 2. Remove the first element from O. 3. If there does not exist an element V of O such that same value, R, V, is true, then let desk be object, R. If desk is not undefined, then A append R to O. B if desk is true, return create I to result object, R. False, C set object to object, D set O to object, E set O to false, F if object is null, return create I to result object, undefined, true, 4, 7, 5, 1, 0, 3 properties of for an iterator instances. For an iterator instances are ordinary objects that inherit properties from the % for an iterator prototype % intrinsic object. For an iterator, instances are initially created with the internal slots listed in Table 39. 12. Copyright sign, ECMA International 2024. Table 39. Internal slots of for an iterator instances. Internal slot. Type, description, object, an object. The object value whose properties are being iterated. Object was visited. A boolean, true if the iterator has invoked on. False otherwise. Visited keys, a list of strings. The values that have been emitted by this iterator thus far. Remaining keys, a list of strings. The values remaining to be emitted for the current object. Before iterating the properties of its prototype. If its prototype is not null. 14.8. The continue statement syntax. Continue statement, yield, await, continue, continue. No line terminator here. Label identifier yield await. 148. 1 static semantics. Early errors. Continue statement. Continue. Continue label identifier. It is a syntax error if this continue statement is not nested, directly or indirectly, and not crossing function or static initialization block boundaries within an iteration statement. 148. To runtime semantics. Evaluation. Continue statement. Continue. Return completion record. Continue. Empty. Empty. Continue statement. Continue label identifier. Let label be the string value of label identifier. Return completion record. Continue. Empty. Label. 4.9. The break statement syntax. Break statement. Yield. Await. Break. Break. No line terminator here. Label identifier yield await. 149. 1 static semantics. Early errors. Break statement. Break. ECMA International 2024. 13. Comma it is a syntax error if this break statement is not nested, directly or indirectly, and not crossing function or static initialization block boundaries within an iteration statement or a switch statement. 4. 9. To runtime semantics. Evaluation. Break statement. Break. Return completion record. Break. Empty. Empty. Break statement. Break label identifier. Let label be the string value of label identifier. Return completion record. Break. Empty. Label. 4.10. The turn statement syntax. Return statement. Yield. Await. Return. Return. No line terminator here. Expression. Class and yield await. 4. 1 0. 1 runtime semantics. Evaluation. Return statement. Return. Return completion record. Return. Undefined. Empty. Return statement. Return expression. Let x the ref be. Evaluation of expression. Let x per value be. Get value. X per ref. If get generator kind is a sync. Set x per value to. Await. X per value. Return completion record. Return. X per value. Empty. A return statement causes a function to cease execution and, in most cases, returns a value to. Note the caller. If expression is omitted, the return value is undefined. Otherwise, the return value is the value of expression. A return statement may not actually return a value to the caller depending on surrounding context. For example, in a try block, a return statement's completion record may be replaced with another completion record during evaluation of the finally block. Legacy. 4.11 Fewth statement. Note one use of the legacy with statement is discouraged in new ECMA script code. Consider alternatives that are permitted in both strict mode code and non-strict code, such as destructuring assignment. 14. ECMA International 2024. Syntax. With statement, yield, await, return, with expression, plus and yield await. Statement yield await return. 4. 1 1. 1 static semantics. Early errors. With statement, with expression statement. It is a syntax error if the source text matched by this production is contained in strict mode code. It is a syntax error if is labeled function. Statement is true. Note it is only necessary to apply the second rule if the extension specified in b3.1 is implemented. 4. 1 1. To runtime semantics. Evaluation. With statement, with expression statement. Let val be. Evaluation of expression. Let obj be. Subject. Get value. Val. Let old env be the running execution context's lexical environment. Let new env be new object environment. Obj. True. Old env. Set the running execution context's lexical environment to new env. Let c be completion. Evaluation of statement. Set the running execution context's lexical environment to old env. Return. Update empty. C. Undefined. Note 2. The with statement adds an object environment record for a computed object to the lexical environment of the running execution context. It then executes a statement using this augmented lexical environment. Finally, it restores the original lexical environment. Note no matter how control leaves the embedded statement, whether normally or by some form of abrupt completion or exception, the lexical environment is always restored to its former state. 4.12 Switch statement syntax. Switch statement, yield, await, return, switch, expression, plus and yield await. Case block yield await return. Case block. Yield, await, return, case clauses yield await return opt, case clauses yield await return opt, default clause yield await return, case clauses yield await return opt, case clauses, yield, await, return, case clause yield await return, case clauses yield await return, case clause yield await return. ECMA International 2024 315, case clause, yield, await, return, case expression, plus and yield await, statement list yield await return opt, default clause, yield, await, return, default, statement list yield await return opt. 4. 1 2. 1 static semantics. Early errors. Switch statement. Switch. Expression. Case block. It is a syntax error if the lexically declared names of case block contains any duplicate entries. It is a syntax error if any element of the lexically declared names of case block also occurs in the are declared names of case block. 4. 1 2. To runtime semantics. Case block evaluation. The syntax-directed operation case block evaluation takes argument input, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Case block. Return undefined. Case block. case clauses. Let v be undefined. Let b be the list of case clause items in case clauses. In source text order, let found be false. For each case clause C of A, do if found is false, then I set found 2. Case clause is selected. C. Input B if found is true. Then I let R be completion. Evaluation of C. 2. If R is not empty, set V to R. E. 3. If R is an abrupt completion, return. Update empty. R. V. Return V. Case block. Case clause assopt. Default clause case clause assopt. Let V be undefined. If the first case clause is present, then a let A be the list of case clause items in the first case clauses. In source text order 3. Else a let A be a new empty list. Let found be false. For each case clause C of A, do if found is false, then I set found 2. Case clause is selected. C. Input B if found is true. Then I let R be completion. Evaluation of C. 2. If R is not empty, set V to R. 3. If R is an abrupt completion, return. Update empty. R. V. Let found INB be false. If the second case clause is present, then a let B be the list of case clause items in the second case clauses. In source text order 8. Else a let B be a new empty list 9. If found is false, then 16. ECMA International 2024. For each case clause C of B, do I have found INB is false, then set found INB to. Case clause is selected. C. Input 2. If found INB is true, then let R be completion. Evaluation of case clause C. If R is not empty, set V to R. If R is an abrupt completion, return. Update empty. R. V. 0. If found INB is true, return V. 1. Let defaulter be completion. Evaluation of default clause 2. If defaulter is not empty, set V to defaulter. 3. If defaulter is an abrupt completion, return. Update empty. Defaulter. V. 4. Note, the following is another complete iteration of the second case clauses. 5. For each case clause C of B, do a let R be completion. Evaluation of case clause C. B if R is not empty, set V to R. C if R is an abrupt completion, return. Update empty. syntax error if function body contains supercall is true. Function body, function statement list. It is a syntax error if the lexically declared names of function statement list contains any duplicate entries. Note the lexically declared names of a function body does not include identifiers bound using var or function declarations. ECMA International 2024 327. It is a syntax error if any element of the lexically declared names of function statement list also occurs in the var declared names of function statement list. It is a syntax error if contains duplicate labels of function statement list with argument is true. It is a syntax error if contains undefined break target of function statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of function statement list with arguments and is true. 5.2. Static semantics. Function body contains use strict. The syntax directed operation function body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Function body, function statement list. If the directive prologue of function body contains a use strict directive, return true. Otherwise, return false. 5.2. 3 runtime semantics. Evaluate function body. The syntax directed operation evaluate function body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Function body, function statement list. Perform. Capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I function object arguments list. Return. Evaluation of function statement list. 5.2. For runtime semantics. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital O B J. The syntax directed operation. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital O B J takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions. Function declaration, function binding identifier, formal parameters, function body. Let name be string value of binding identifier. Let source text be the source text match by function declaration. Let f be ordinary function create. Function prototype source text. Formal parameters. Function body. Non-lexical this. env. Private env. Perform set function name. F. Name. Perform make constructor. F. Return f. Function declaration. Function. Formal parameters. Function body. Let source text be the source text match by function declaration. Let f be ordinary function create. Function prototype source text. Formal parameters. Function body. Non-lexical this. env. Private env. Perform set function name. F. Default. Perform make constructor. F. Return f. 328. ECMA International 2024. An anonymous function declaration can only occur as part of an expo RT default declaration. Note, and its function code is therefore always strict mode code. 1.5.2. 5 runtime semantics. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P. The syntax directed operation. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions. Function expression, function, formal parameters, function body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text match by function expression. Let closure be ordinary function create. Function prototype source text. Formal parameters. Function body. Non-lexical this. env. Private env. Perform set function name. Closure. Name. Perform make constructor. Closure. Return closure. Function expression. Function binding identifier. Formal parameters. Function body. Assert. Name is not present. Set name to string value of binding identifier. Let outer env be the running execution context's lexical environment. Let funky env be new declarative environment. Outer env. Perform funky env create immutable binding. Name. False. Let private env be the running execution context's private environment. Let source text be the source text match by function expression. Let closure be ordinary function create. Percent function prototype percent. Source text. Formal parameters. Function body. Non-lexical this. Funct env. Private env. Perform set function name. Closure. Name 0. Perform make constructor. Closure 1. Perform func env initialize binding. Name. Closure 2. Return closure 5. 2. 6 runtime semantics. Evaluation. Function declaration. Function binding identifier. Formal parameters. Function body 1. Return empty. Note 1 an alternative semantics is provided in B 3.2. Function declaration. Function. Formal parameters. Function body 1. Return empty. Function expression. Function binding identifier. Formal parameters. Function body 1. Return capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P of function expression. Note the binding identifier in a function expression can be referenced from inside the function expression's function body to allow the function to call itself recursively. However, unlike in a function declaration, the binding identifier in a function expression cannot be referenced from and does not affect the scope enclosing the function expression. Note 2 a prototype property is automatically created for every function defined using a function declaration or function expression to allow for the possibility that the function will be used as a constructor. ECMA International 2024 329. Function statement list. Empty. 1. Return undefined. 5.3 arrow function definition syntax. Arrow function in yield await. Arrow parameters yield await. No line to meaner. Tor here equals concise body in capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N yield await. Concise body in look ahead. Expression body in await. Function body yield await. Expression body in await. Assignment expression in yield await. Supplemental syntax when processing an instance of the production. Arrow parameters yield await capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N yield await. The interpretation of capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N is refined using the following grammar. Arrow formal parameters yield await. Unique formal parameters yield await. 5 3 1 static semantics. Early errors. Arrow function. Arrow parameters equals concise body. It is a syntax error if arrow parameters contains yield expression is true. It is a syntax error if arrow parameters contains await expression is true. It is a syntax error if concise body contains use strict of concise body is true and is simple parameter list of arrow parameters is false. It is a syntax error if any element of the bound names of arrow parameters also occurs in the lexically declared names of concise body. Arrow parameters capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N must cover an arrow formal parameters 1 5 3 2 static semantics. Concise body contains use strict. The syntax directed operation concise body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Concise body, expression body, return false. 30. ECMA International 2024. Arrow parameters, yield, await, binding identifier yield await. Concise body, function body, return function body contains use strict of function body. 5 3 3 runtime semantics. Evaluate concise body. The syntax directed operation evaluate concise body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Concise body, expression body, perform. Capital F U N C T I O N capital D E C L A R A T I O function object, arguments list, return, evaluation of expression body, 5, 3, for runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, the syntax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions. Arrow function, arrow parameters equals, concise body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text match by arrow function. Let closure be ordinary function create. Percent function prototype percent, source text, arrow parameters, concise body, lexical this, env, private env, perform set function name, closure, name, return closure. An arrow function does not define local bindings for arguments, super, this, or new target. Note, any reference to arguments, super, this, or new target within an arrow function must resolve to a binding in a lexically enclosing environment. Typically this will be the function environment of an immediately enclosing function. Even though an arrow function may contain references to super, the function object created in step 5 is not made into a method by performing make method. An arrow function that references super is always contained within an on-arrow function, and the necessary state to implement super is accessible via the env that is captured by the function object of the arrow function. 5, 3, 5 runtime semantics, evaluation, arrow function, arrow parameters equals, concise body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, of arrow function, expression body, assignment expression, let x per f be. Evaluation of assignment expression, let x per value be. Get value, x per f, return completion record, return, x per value, empty, ECMA International 2024 331, 15.4 method definition syntax, method definition, yield, await, class element name yield await, unique formal parameters, yield, await, function body, yield, await, generator method yield await, async method yield await, async generator method yield await, get class element name yield await, function body, yield, await, set class element name yield await, property set parameter list, function body, yield, await, property set parameter list, formal parameter, yield, await, 1 5, 4, 1 static semantics, early errors, method definition, class element name, unique formal parameters, function body. It is a syntax error if function body contains use strict of function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of function body. Method definition, set class element name, property set parameter list, function body. It is a syntax error if bound names of property set parameter list contains any duplicate elements. It is a syntax error if function body contains use strict of function body is true and is simple parameter list of property set parameter list is false. It is a syntax error if any element of the bound names of property set parameter list also occurs in the lexically declared names of function body. 5, 4, just static semantics, has direct super. The syntax directed operation has direct super takes no arguments and returns a boolean. It is defined piecewise over the following productions. Method definition, class element name, unique formal parameters, function body. If unique formal parameters contain supercall is true, return true. Return function body contains supercall. Method definition, get class elam and name, function body, 1. Return function body contains supercall. Method definition, set class element name, property set parameter list, function body. If property set parameter list contains supercall is true, return true. Return function body contains supercall. Generator method, class element name, unique formal parameters, generator body. 2. If unique formal parameters contains supercall is true, return true. Return generator body contains supercall. 32. ECMA International 2024. Async generator method. Async class element name. Unique formal parameters. Async generator body. If unique formal parameters contains supercall is true, return true. Return async generator body contains supercall. Async method. Async class element name. Unique formal parameters. Async function body. If unique formal parameters contains supercall is true, return true. Return async function body contains supercall. 5, 4, 3 static semantics. Special method. The syntax directed operation special method takes no arguments and returns a boolean. It is defined piecewise over the following productions. Method definition, class element name, unique formal parameters, function body, return false. Method definition, generator method, async generator method, get class element name, function body, set class element name, property set parameter list, function body, return true. 5, 4, 4 runtime semantics, define method. The syntax-directed operation define method takes argument object, an object, and optional argument function prototype, an object, and returns either a normal completion containing a record with fields, an ECMA script function object, or an abrupt completion. It is defined piecewise over the following productions: method definition, class element name, unique formal parameters, function body, let proc key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. If function prototype is present, then a let prototype be function prototype 5. Else, a let prototype be percent function prototype percent. Let source text be the source text matched by method definition. Let closure be ordinary function create, prototype, source text, unique formal parameters, function body, non-lexical this, env, private env, before make method, closure, object, return the record, closure, ECMA International 2024 333, 154, 5 runtime semantics, method definition evaluation. The syntax-directed operation method definition evaluation takes arguments, object, an object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It is defined piecewise over the following productions: method definition, class element name, unique formal parameters, function body, capital L, at method fb. Define method of method definition with argument object, perform set function name, method def, return. Define method property, object, method def, enumerable, method definition, get class element name, function body, let proc key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by method definition. Let formal parameter list be an instance of the production formal parameters. Empty. Let closure be ordinary function create. Percent function prototype percent. Source text. Formal parameter list. Function body. Non-lexical this. env. Private env. Before make method. Closure. Object. Perform set function name. Closure. Prop key. Get. If prop key is a private name, then a return private element. Accessor. Undefined 10. Else, a let desk be the property descriptor. Enumerable. True. Be perform. Define property or throw. Object. Prop key. Desk. See return unused. Method definition. Set class element name. Property set parameter list. Function body. Let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by method definition. Let closure be ordinary function create. Percent function prototype percent. Source text. Property set parameter list. Function body. Non-lexical this. env. Private env. Before make method. Closure. Object. Perform set function name. Closure. Prop key. Set. If prop key is a private name, then a return private element. Accessor. Closure 9. Else, a let desk be the property descriptor. Enumerable. True. Be perform. Define property or throw. Object. Prop key. Desk. See return unused. Generator method. Class element name. Unique formal parameters. Generator body. Let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by generator method. Let closure be ordinary function create. Percent generator function prototype percent. Source text. Unique formal parameters. Generator body. Non-lexical this. env. Private env. Before make method. Closure. Object. Perform set function name. Closure. Prop key. Let prototype be ordinary object create. Percent generator function prototype percent. 34. ECMA International 2024. 9. Perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. 0. Return. Define method property. Object. Prop key. Closure. Enumerable. Async generator method. Async class element name. Unique formal parameters. Async generator body. Let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by async generator method. Let closure be ordinary function create. Percent async generator function prototype percent. Source text. Unique formal parameters. Async generator body. Non-lexical this. env. Private env. Before make method. Closure. Object. Perform set function name. Closure. Prop key. Let prototype be ordinary object create. Percent async generator function prototype percent. Perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. 0. Return. Define method property. Object. Prop key. Closure. Enumerable. Async method. Async class element name. Unique formal parameters. Async function body. Let prop key be. Evaluation of class element name. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async method. Let closure be ordinary function create. Percent async function prototype percent. Source text. Unique formal parameters. Async function body. Non-lexical this. env. Private env. Before make method. Closure. Object. Perform set function name. Closure. Prop key. Return. Define method property, object, prop key, closure, enumerable, 5.5 generator function definition syntax, generator declaration, yield, await, default, function binding identifier yield await, formal parameters, plus yield, await, generator body, plus default, function, formal parameters, plus yield, await, generator body, generator expression, function binding identifier, plus yield, await opt formal parameters, plus yield, await, generator body, generator method, yield, await, class element name yield await, unique formal parameters, plus yield, await, generator body, function body, plus yield, await, yield expression, in, await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await, ECMA International 2024 335. Note 2 yield expression cannot be used within the formal parameters of a generator function because any expressions that are part of formal parameters are evaluated before the resulting generator is in a reasonable state. Note 3 abstract operations relating to generators are defined in 2.7.5.3.1.5.5.1 static semantics, early errors, generator method, class element name, unique formal parameters, generator body. It is a syntax error if has direct super generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is a syntax error if function body contains use strict of generator body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of generator body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier opt, formal parameters, generator body. If the source text matched by formal parameters is strict mode code, the early error rules for unique formal parameters are applied. If binding identifier is present and the source text matched by binding identifier is strict mode code, it is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if generator body contains super property is true. It is a syntax error if formal parameters contains super call is true. It is a syntax error if generator body contains super call is true. 5. To runtime semantics, evaluate generator body. The syntax directed operation evaluate generator body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a throw completion or a return completion. It is defined piecewise over the following productions: generator body, function body, perform, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object, arguments list, let GB, ordinary create from constructor, function object, percent generator function prototype, percent, generator brand, set G to empty, perform generator start, G, function body, return completion record, return, G, empty, 36, ECMA International 2024. Note 1 the syntactic context immediately following yield requires use of the capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, lexical goal, 1.5.5.3 runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, the syntax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, takes argument CNV, an environment record, and private ENV, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions: generator declaration, function binding identifier, formal parameter, generator body, let name be string value of binding identifier, let source text be the source text matched by generator declaration, let f be ordinary function create, percent generator function prototype, percent, source text, formal parameters, generator body, non-lexical this, env, private env, perform set function name, f, name, let prototype be ordinary object create, percent generator function prototype, percent, perform, define property or throw, f, prototype, property descriptor, prototype, true, false, return f, generator declaration, function, formal parameters, generator body, let source text be the source text matched by generator declaration, let f be ordinary function create, percent generator function prototype, percent, source text, formal parameters, generator body, non-lexical this, env, private env, perform set function name, f, default, let prototype be ordinary object create, percent generator function prototype percent perform, define property or throw, f, prototype, property descriptor, prototype, true, false, false, return f, 5, 5, for runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital E, X, the syntax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital E, X, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: generator expression, function, formal parameters, generator body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by generator expression. Let closure be ordinary function create, percent generator function prototype percent, source text, formal parameters, generator body, non-lexical this, env, private env, perform set function name, closure, name. Let prototype be ordinary object create, percent generator function prototype percent, perform, define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, false, return closure, generator expression, function binding identifier, formal parameters, generator body, assert, name is not present, set name to string value of binding identifier. Let outer env be the running execution context's lexical environment. Let funky env be new declarative environment. Outer env, perform funky env create immutable binding, name, false. Let private env be the running execution context's private environment. Let source text be the source text matched by generator expression. An anonymous generator declaration can only occur as part of an export default declaration. Note, and its function code is therefore always strict mode code. ECMA International 2024, 337, 8. Let closure be ordinary function create, percent generator function prototype percent, source text, formal parameters, generator body, non-lexical this, funct env, private env, perform set function name, closure, name, 0. Let prototype be ordinary object create, percent generator function prototype percent, 1. Perform, define property or throw, closure, prototype, property descriptor, prototype, true, false, false, 2. Perform funky env initialize binding, name, closure, 3. Return closure, 5, 5. 5 runtime semantics, evaluation, generator expression, function binding identifier opt, formal parameters, generator body, 1. Return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital E, X, of generator expression, yield, return, yield, undefined, yield expression, yield assignment expression, let x per f be, evaluation of assignment expression, let value be, get value, x per f, return, yield, value, yield expression, yield assignment expression, let generator kind be get generator kind, let x per f be, evaluation of assignment expression, let value be, get value, x per f, let iterator record be, get iterator, value, generator kind, let iterator be iterator record, let received be normal completion, undefined, repeat. Note the binding identifier in a generator expression can be referenced from inside the generator expression's function body to allow the generator code to call itself recursively. However, unlike in a generator declaration, the binding identifier in a generator expression cannot be referenced from and does not affect the scope enclosing the generator expression. 38. ECMA International 2024. A. B. If received is a normal completion, then I let in a result B. Call, iterator record, received 2. If generator kind is a sync, set in a result 2. Await, in a result 3. If in a result is not an object, throw a type error exception. I've looked on B. Iterator complete, in a result V. If done is true, then return. Iterator value, in a result V. If generator kind is a sync, set received to completion, async generator yield, iterator value, in a result 7. Else, set received to completion, generator yield, in a result. Else if received is a throw completion, then I2, last throw B. Get method, iterator, throw. If throw is not undefined, then 2, 3, 5. Let in a result B. Call, throw, iterator, received. If generator kind is a sync, set in a result 2. Await, in a result. Note, exceptions from the inner iterator throw method are propagated. Normal completions from an inner throw method are processed similarly to an inner next. If in a result is not an object, throw a type error exception. Looked on B. Iterator complete, in a result. 15.6 syntax. If done is true, then a return. iterator value, in a result, if generator kind is ASCII, NC, set received to completion, async generator yield, iterator value, in a result, else, set received to completion, generator yield, in a result, 3, else, note, if iterator does not have a throw method, this throw is going to terminate the yield loop. But first we need to give iterator a chance to clean up. Let close completion be completion record, normal, empty, empty, if generator kind is async, perform, async iterator close, iterator record, close completion, else, perform, iterator close, iterator record, close completion. Note, the next step throws a type error to indicate that there was a yield protocol violation. Iterator does not have a throw method 6. Throw type error exception, see else, assert, received as a return completion. 2. Let return be, get method, iterator, return. 3. If return is undefined, then set value to received. If generator kind is async, then a set value to await value, return completion record, return value, empty. 5. Let in a return result be call, return, iterator, received v. If generator kind is async, set in a return result. 2. Await, in a return result v. If in a return result is not an object, throw a type error exception. 7. Let done be, iterator complete, in a return result. 8. If done is true, then set value to iterator value, in a return result, return completion record, return value, empty. 9. If generator kind is async, set received to completion, async generator yield,
Iterator value, innerretum resultat.
X else, set received to completion, generator yield, in a return result, async generator function definitions, async generator declaration, yield, await, default, async, no line terminator here, function binding identifier yield await, formal parameters, class yield, class await, async generator body, class default, async, no line terminator here, function, formal parameters, class yield, class await, async generator body, async generator expression, async, no line terminator here, function binding identifier, class yield, class await opt, formal parameters, class yield, class await, async generator body, async generator method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, class yield, class await, async generator body, function body, class yield, class await, ECMA International 2024, 39. Note 1 yield expression and await expression cannot be used within the formal parameters of an async generator function because any expressions that are part of formal parameters are evaluated before the resulting async generator is in a reasonable state. Note 2 abstract operations relating to async generators are defined in 2.7, 6, 3, 1, 5, 6, 1 static semantics, early errors, async generator method, async class element name, unique formal parameters, async generator body. It is a syntax error if has direct super of async generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async generator expression, async function binding identifier opt, formal parameters, async generator body. If the source text match by formal parameters is strict mode code, the early error rules for unique formal parameters are applied. If binding identifier is present in the source text match by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error if formal parameters contains await expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if async generator body contains super property is true. It is a syntax error if formal parameters contains super call is true. It is a syntax error if async generator body contains super call is true. 5, 6. To runtime semantics, evaluate async generator body. The syntax directed operation evaluate async generator body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a throw completion or a return completion. It is defined piecewise over the following productions: async generator body, function body, perform, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object, arguments list. Let generator be ordinary create from constructor, function object, percent async generator function prototype percent, async generator context, set generator to empty, perform async generator start, generator, function body, return completion record, return, generator, empty, 40, ECMA International 2024, 1, 5, 6, 3 runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T. The The syntax directed operation, capital I N S T A N T I A T E, capital A S Y N C, capital G E N E R A T O R, capital F U N C T, takes argument CNV, an environment record, an dprivate TNV, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions: a sync generator declaration, a sync function binding identifier, formal parameters, a sync generator body, let name be string value of binding identifier, let source text be the source text matched by a sync generator declaration, let f be ordinary function create, percent a sync generator function prototype, percent, source text, formal parameters, a sync generator body, non-lexical this, env, private env, perform set function name, f, name, let prototype be ordinary object create, percent a sync generator function prototype, percent, perform, define property or throw, f, prototype, property descriptor, prototype, true, false, false, return f, a sync generator declaration, a sync function, formal parameters, a sync generator body, let source text be the source text matched by a sync generator declaration, let f be ordinary function create, percent a sync generator function prototype, percent, source text, formal parameters, a sync generator body, non-lexical this, env, private env, perform set function name, f, default, let prototype be ordinary object create, percent a sync generator function prototype, percent, perform, define property or throw, f, prototype, property descriptor, prototype, true, false, false, return f, 5, 6, for runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, the syntax directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: a sync generator expression, a sync function, formal parameters, a sync generator body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync generator expression. Let closure be ordinary function create. Percent a sync generator function prototype, percent, source text, formal parameters, a sync generator body, non-lexical this, env, private env, perform set function name, closure, name, let prototype be ordinary object create, percent a sync generator function prototype, percent, perform, define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, false, return closure, a sync generator expression, a sync function binding identifier, formal parameters, a sync generator body, assert, name is not present, set name to string value of binding identifier, let outer env be the running execution context's lexical environment, let funky env be new declarative environment, outer env, perform funky env create immutable b, ding, name, false, an anonymous async generated declaration can only occur as part of an export default. Note, declaration, ECMA International 2024 341, 6. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync generator expression. Let closure be ordinary function create. Percent a sync generator function prototype, percent, source text, formal parameters, a sync generator body, non-lexical this, funct env, private env, perform set function name, closure, name, 0. Let prototype be ordinary object create, percent a sync generator function prototype, percent, 1. Perform, define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, false, 2. Perform func env initialize binding, name, closure, 3. Return closure, 5, 6, 5 runtime semantics, evaluation, a sync generator expression, a sync function binding identifier, formal parameters, a sync generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, of the sync generator expression, 5.7 class definition syntax, class declaration, yield, await, default, class binding identifier yield await, class tail yield await, class default, class tail yield await, class expression, yield, await, class binding identifier yield await op, class tail yield await, class tail, yield, await, class heritage yield await op, class body yield await opt, class heritage, yield, await, extends left-hand side expression yield await, class body, yield, await, class element list yield await, class element list, yield, await, class element yield await, class element list yield await, class element yield await, class element, yield, await, method definition yield await, static method definition yield await, field definition yield await, static field definition yield await, class static block. Note the binding identifier in an async generator expression can be referenced from inside the async generator expression's async generator body to allow the generator code to call itself recursively. However, unlike in an async generator declaration, the binding identifier in an async generator expression cannot be referenced from and does not affect the scope enclosing the async generator expression. 42. ECMA International 2024. Field definition, yield, await, class element name yield await, initializer, class and yield await opt, class element name, yield, await, property name yield await, private identifier class static block, static, class static block body, class static block body, class static block statement list, class static block statement list, yield, class await, return opt. Note a class definition is always strict mode code. 5, 7, 1 static semantics, early errors, class tail, class heritage art, class body. It is a syntax error if class heritage is not present in the following algorithm returns true. Let constructor be go. Constructor method of class body. If constructor is empty, return false. Return has direct super of constructor. Class body, class element list. It is a syntax error if prototype property name list of class element list contains more than one occurrence of constructor. It is a syntax error if private bound identifiers of class element list contains any duplicate entries, unless the name is used once for a getter and once for a setter and in no other entries, and the getter and setter are either both static or both non. Static, class element, method definition. It is a syntax error if prop name of method definition is not constructor and has direct super of method definition is true. It is a syntax error if prop name of method definition is constructor and special method of method definition is true. Class element, static method definition. It is a syntax error if has direct super of method definition is true. It is a syntax error if prop name of method definition is prototype. Class element, field definition. It is a syntax error if prop name of field definition is constructor. Class element, static field definition. It is a syntax error if prop name of field definition is either prototype or constructor. Field definition, class element name initializer opt. It is a syntax error if initializer is present and contains arguments of initializer is true. Copyright sign, ECMA International 2024 343, comma it is a syntax error if initializer is present and initializer contains supercall is true. Class element name, private identifier. It is a syntax error if string value of private identifier is constructor. Class static block body, class static block statement list. It is a syntax error if the lexically declared names of class static block statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of class static block statement list also occurs in the var declared names of class static block statement list. It is a syntax error if contains duplicate labels of class static block statement list with argument is true. It is a syntax error if contains undefined break target of class static block statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of class static block statement list with arguments and is true. It is a syntax error if contains arguments of class static block statement list is true. It is a syntax error if class static block statement list contains supercall is true. It is a syntax error if class static block statement list contains await is true. 5, 7, 2 static semantics, class element kind. The syntax directed operation class element kind takes no arguments and returns constructor method, non-constructor method, or empty. It is defined piecewise over the following productions. Class element, method definition. If prop name of method definition is constructor, return constructor method, return non-constructor method. Class element, static method definitio, n, field definition, static field definition, return non-constructor method. Class element, class static block, return non-constructor method. Class element, return empty. 5, 7, 3 static semantics, constructor method. The syntax directed operation constructor method takes no arguments and returns a class element parse no door empty. It is defined piecewise over the following productions. Class element list, class element. If class element kind of class element is constructor method, return class element, return empty. Class element list, class element list, class element. 2. Let head be constructor method of class element list. If head is not empty, return head. 44. ECMA International 2024. 3. If class element kind of class element is constructor method, return class element, return empty. 5, 7, 4 static semantics, is static. The syntax directed operation is static takes no arguments and returns a boolean. It is defined piecewise over the following productions. Class element, method definition, return false. Class element, static method definition, return true. Class element, field definition, return false. Class element, static field definition, return true. Class element, class static block, return true. Class element, return false. 5, 7, 5 static semantics, non-constructor elements. The syntax directed operation non-constructor elements takes no arguments and returns a list of class element parse nodes. It is defined piecewise over the following productions. Class element list, class element. If class element kind of class element is non-constructor method, then a return class element, return a new empty list. Class element list, class element list, class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method, then a append class element to the end of list 3. Return list. Note early error rules ensure that there is only one method definition named constructor and that it is not an accessor property or generated definition. ECMA International 2024 345. 1576 Static semantics. Prototype property name list. The syntax-directed operation prototype property name list takes no arguments and returns a list of property keys. It is defined piecewise over the following productions. Class element list. Class element. Let prop name be prop name of class element. If prop name is empty, return a new empty list. If the static of class element is true, return a new empty list. Return prop name, class element list, class element list, class element. Let list be prototype property name list of class element list. Let prop name be prop name of class element. If prop name is empty, return list. If the static of class element is true, return list. Return the list concatenation of list and prop name. 577 Static semantics. All private identifiers valid. The syntax-directed operation all private identifiers valid takes argument name s, a list of strings, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of all private identifiers valid. For each child of this parse node. Do A if child is an instance of a non-terminal, then I if all private identifiers valid of child with argument names is false. Return false 2. Return true. Member expression. Private identifier. If names contains the string value of private identifier, then I return all private identifiers valid of member expression with argument names. Return false. Call expression. Private identifier. If names contains the string value of private identifier, then I return all private identifiers valid of call expression with argument names. Return false. Optional chain. Private identifier. If names contains the string value of private identifier, return true. Return false. Optional chain. Private identifier. If names contains the string value of private identifier, then I return all private identifiers valid of optional chain with argument names. Return false. Class body. Class element list. 2. Let new names be the list concatenation of names and private band identifiers of class body. Return all private identifiers valid of class element list with argument new names. 46. ECMA International 2024. Relational expression. Private identifier and shift expression. If names contains the string value of private identifier, then I return all private identifiers valid of shift expression with argument names. Return false. 5, 7, 8 Static semantics. Private bound identifiers. The syntax-directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Field definition. Class element name initial is rot. Return private bound identifiers of class element name. Class element name. Private identifier. Return list whose sole element is the string value of private identifier. Class element name. Property name. Class element. Class static block. Return a new empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async method. Async class element name. Unique formal parameters. Async function body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return private bound identifiers of class element name. 5, 7, 9 Static semantics. Contains arguments. The syntax-directed OPA. Ashen contains arguments, takes no arguments and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following. Default definition of contains arguments. For each child of this parse node. Do A if child is an instance of a non-terminal, then I if contains arguments if child is true. Return true 2. Return false. ECMA International 2024 347. Identifier reference. Identifier. If the string value of identifier is arguments, return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier. Formal parameters. Function body. Generator declaration. Function binding identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier. Formal parameters. Generator body. Async generator declaration. Async function binding identifier. Formal parameters. Async generator body. Async function. Formal parameters. Async generator body. Async generator expression. Async function binding identifier. Formal parameters. Async generator body. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Async function. Formal parameters. Async function body. Async function expression. Async function binding identifier. Formal parameters. Async function body. Return false. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Async method. Async class element name. Unique formal parameters. Async function body. Return contains arguments of class element name. The 5th of July 2010 runtime semantics. Class field definition evaluation. The syntax-directed operation class field definition evaluation takes argument home object, an object, and returns either a normal completion containing a class field definition record or an abrupt completion. It is defined piecewise over the following productions. Field definition. Class element name initial is rot. 2. Let name be. Evaluation of class element name. If initializer is present, then 48. ECMA International 2024. ABCDE. Let formal parameter list be an instance of the production formal parameters. Empty. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let initializer be ordinary function create. Function prototype source text. Formal parameter list. Initially, there. Non-lexical this. env. Private env. F perform make method. Initializer. Home object. G set initializer to name. Else. Let initializer be empty. Return the class field definition record. Name. Initializer. Note the function created for initializer is never directly accessible to ECMA script code. The 5th of July 2011 runtime semantics. Capital C L A S S. Capital S T A T I C. Capital B L O C K. Capital D E F I N I T I O N. Capital E V A L. The syntax directed operation. Capital C L A S S. Capital S T A T I C. Capital B L O C K. Capital D E F I N I T I O N. Capital E V A L. Takes argument home object, an object, and returns a class static block definition record. It is defined piecewise over the following productions. Class static block. Static. Class static block body. Let lex be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let formal parameters be an instance of the production formal parameters. Empty. Let body function be ordinary function create. Function prototype source text. Formal parameters. Class static block body. Non-lexical this. Lex. Private env. Perform make method. Body function. Home object. Return the class static block definition record. Body function. Note the function body function is never directly accessible to ECMA script code. The 15th of July 2012 runtime semantics. Evaluate class static block body. The syntax directed operation evaluate class static block body takes argument function object, an ECMA script function object, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Class static block body. Class static block statement list. Assert. Function object is a synthetic function created by capital C L A S S capital S T A T I C capital B L O C K capital D E F I N I T I O N capital E V A L. Step 5. Perform. Capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I. Function object. Return. Evaluation of class static block statement list. STS is a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor. Target desk is true and target desk is false. Then I have same value. Trap result. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true and target desk 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. V. Receiver. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor. Target desk is true and target desk is false, then I have same value. V. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true, then I have target desk 1. Return true. Note, the result of boolean value cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note the proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible. Target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target. Key be if desk is not undefined and desk able is false. Then I append key to target non-configurable keys. C else I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note the proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. get method, handler, apply. If trap is undefined, then a return. Call, target, this argument, arguments list. Let array be create array from list, arguments list. Return, call, trap, handler, target, this argument, array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024-211, the 10th of May 2013, arguments list, new target. The internal method of a proxy exotic object O takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O, assert, is constructor, target, is true. Let handler be O, assert, handler is an object. Let trap be. Get method, handler, construct. If trap is undefined, then a return. Construct, target, arguments list, new target. Let array be create a from list, arguments list. Let new obj be. Call, trap, handler, target, array, new target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert, proxy is not null. Return unused. 0, 5, 1 5 proxy create, target, handler. The abstract operation proxy create takes arguments target, an ECMA script language value, and handler, an ECMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let p be make basic object. Set p's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then a set p is specified in the 10th of May 2012. B if is constructor, target, is true, then I set p is specified in the 10th of May 2013. Set p to target, set p to handler, return p, 12. ECMA International 2024. Note 1 a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMA script language. Source text. 1.1 source text syntax. Source character. Any Unicode code point. ECMA script source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMA script source text where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMA script implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMA script implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression light, rals, template literals and identifiers. Any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMA script differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U+000a is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000a occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000a to cause a line feed, LF, to be part of the string value of a string literal. In an ECMA script program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics. UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert. 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let co1 be the code unit whose numeric value is floor. CP0 times 10,000, 0 times 400 plus 0 xd800. Let co2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 xdc00. Return a string concatenation of co1 and co2. ECMA International 2024-213. 1. 2 static semantics. Code points to string, text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1, 1. 3 static semantics. UTF-16 surrogate pair to code point led trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit and trail a code unit and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0xd800. 0 times 400 plus trail 0xdc00 plus 0 times 10,000. Return the code point CP 1, 1. 4 static semantics. Code point it. String. Position. The abstract operation code pointed takes a argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position, size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If the first is neither a leading surrogate nor a trailing surrogate, then I return the record. CP 1, full 6. If the first is a trailing surrogate or position plus 1 equals size, then I return the record. CP 1, true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then I return the record. CP 1, true. Set CP to UTF-16 surrogate pair to code point first, second, 0. Return the record. CP 2, false 1, 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6, 1, 4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string. Position be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 1, 1, 1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 types of source code. There are 4 types of ECMA script code. Global code is source text that is treated as an ECMA script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMA script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is passed to supply the value of the internal slots, C10.2, of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is passed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is passed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1 function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1, the generator function constructor 27, 3, 1, 1, and the async function constructor 27, 7, 1, 1. Note 2 the practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2, 2 strict mode code. Any CMA script syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMA script code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1, 1, 2, 3 non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA script source text. Whether a function object is defined with an ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element #bang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion. See 12.10 in examples such as the following: equals b high g exec, c map, d, where the first non-white space, Non-comment code point after a line terminator is U+002F, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as up equals b high g exec, cmap, d, syntax, input element of, white space, line terminator comment token div punctuator right brace punctuator, input element reg exp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuator template substitution tail, input element hashbang or reg exp, white space, line terminator comment token hashbang comment regular expression literal, 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher-level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U+200C, 0-width non-joiner, and U+200D, 0-width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMA script source text, these code points may also be used in an identifier name after the first character. U+F, 0-width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding in byte order. ZWNBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMA script source text, ZWNBSP, code points are treated as white space characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U+200C 0-width non-joiner ZWNJ identify part U+200D 0-width joiner ZWJ identify part U+F 0-width no break space ZWNBSP white space 218 ECMA International 2024 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMA script white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U+0009. Character tabulation. Tab. U+000B. Line tabulation. VT. U+000C. Form feed. FF. U+F. 0-width no break space. ZWNBSP. Any code point in general category space separator. USP. No one U+0020. Space. And U+00A0. No break space. Code points are part of USP syntax. Note 2. Other than for the code points listed in Table 36, ECMA script white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS. 2.3. White space. Tab. VT. FF. ZWNBSP. USP. Line terminators. Like white space code points, line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. MCR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024 219. The ECMA script line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U+000 line feed. LF. U+000D. Carriage return CR. U+2028. Line separator. LS. U+2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax, line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of passing by the syntactic grammar. Syntax, comment, multi-line comment, single line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not one of all, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt, single line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax, hashbang comment, single line comment charsopt, 2.6 tokens syntax, common token, identifier name, private identifier punctuator numeric literal string literal template. Note the punctuator, regular expression literal, right brace punctuator, and template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard and X number 31, identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode Standard. The Unicode code points in the specified categories in the latest version of the Unicode Standard must be treated as in those categories by all conforming ECMA script implementations. ECMA script implementations may recognize identifier code points defined in later editions of the Unicode Standard. Syntax, private identifier, identifier name, identifier start, identifier name, identifier part, identifier start char, Unicode escape sequence, identifier part char, Unicode escape sequence, identifier start char, Unicode ID start, underscore, identifier part char, Unicode ID continue, ZWNJ, ZWJ, a CI letter, one of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital B, capital C, capital D, not but Gustavs, Unicode ID start, any Unicode code point with the Unicode property ID start, Unicode ID continue, any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 129.4. Note 1. This standard specifies specific code point additions, U+0024, $, and U+005F, low line, are permitted anywhere in an identifier name, and the code points U+200C, 0 width non-joiner, and U+200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent according to the Unicode standard and not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2. 7. 1. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point, matched by the identifier start char lexical grammar production. Identify part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2, 7, 1, 2 static semantics. Identifier code points. The syntax directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions. Identifier name, identifier start. Let CP be identifier code point of identifier start. Return CP, identifier aim, identifier name, identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2, 7, 1, 3 static semantics. Identifier code point. The syntax directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions. Identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3 the sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identify part. Identify part char. Return the code point matched by identify part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2, 7, 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of ECMA script include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts of and while a reserved words await is reserved only inside async functions and modules async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names, those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield, those that are contextually allowed as identifiers, namely await and yield, those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall L in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax, reserved word, 1 of, await break case catch class const continue debug delete do, else enum export extends false finally for function of import and instantia of new null return super switch this throw true try type of var void well with a yield. 24, ECMA International 2024. Note 1 per 5, 1, 5, keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 punctuator syntax. Punctuator, optional chaining punctuator. Other punctuator, optional chaining punctuator. Look ahead decimal digit. Other punctuator, 1 of, comma equals, 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 plus, percent plus plus, and, equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. The punctuator, equals sign. Right brace punctuator, 2.9 literals, 2, 9, 1 null literals syntax. Null literal, null. ECMA International 2024 225. 1, 2, 9, 2 boolean literals syntax. Boolean literal, true, false. 2, 9, 3 numeric literals syntax. Numeric literal separator. Numeric literal, decimal literal. Decimal big integer literal non-decimal integer literal. Plus sep, non-decimal integer literal. Plus sep, begin literal suffix legacy octal integer literal.
This is just as bad as C#. This is terrible. This is ridiculous. And chatbot is basically not AI. This is so frustrating. Okay, so right now there's a spinning box. I need to undo what I was just doing. I'm not gonna waste time making another freaking thing. Alright, I want to figure out what code's running to make the quad. Real simple. I'm not gonna go on a quest with chatbot and put together its fucking shit. Because it just keeps going in a loop. And it's like, oh, now you need to restart. Oh, we gotta restart again. Oh, now you gotta do this. Oh my god. That's like, that's a lot to call every frame at some point. It's like, you should just add initialization. And it's like, it doesn't even know what the fuck it's doing. Yeah, okay. I just had to be done. This is so stupid. Alright, so this is called for the main triangle. The one triangle, like the triangle. This is called for the quad triangle. So I'm gonna rename it. Call it quad angle. So the triangle has two shaders or whatever. The vertex and the fragment. It's got this shit here. All the stuff, whatever. Makes pipeline. Does whatever the fuck this is. And yeah, that's it. And this is a quad. And that's it. So this makes the quad. Does this specify the color of the quad? Yes, it does. I think right here. Except right now, it's like, I think it wants a color. Alright, chatbot, how to make the quad blue. Real simple. Maximize chatbot. If the color is applied inside of the fragment shader. See if this works. Oh my god. Why did I waste so much time asking chatbot? Yeah, no. Just chatbot's not, whatever. Okay, so it's asking chatbot to make something new. I'm gonna just have it modify what I already have. Let's ask chatbot why it's black. Because there's no color on the triangle. Okay, so out vector 2 drag v is in right here. So that's the relation between that. I shouldn't have to figure this out. Chatbot should be able to do it for me. We waste my time figuring it out. Damn it. There's no way to ever pay money for this crap. Freaking chatbots waste money. Is this what's wrong? Is this what was wrong the whole time? Okay, so if I set frag UV, I set frag UV. to UVS, whatever the heck that means. It's right here. And GL vertex index. Let's just send a color to out frag UV. And it didn't, so I'm gonna tweak it and see if it does. If it does, I'm gonna be really annoyed. If it does, this is all ChatSpot fault in the first place. For telling me to comment out this originally. Oh, I'd be so pissed. But I'm gonna not get angry, I'm just gonna already accepted it. Oh my god, why did this not jab up? So I guess it is broken. put this back in the main. As a frag file, send to the particle file, or whatever it's called. Or is it the other way? Oh, it's so boring. So what it is from the vertex to the fragment. So it'll output a color from the vertex to the fragment shader.
Capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L,
Declaring an output variable
capital D, E, C, I,
in the vertex shader.
capital I, N, T, E, G, E, R, capital L, non-octal digit, non-octal decimal, integer, literal decimal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, 0 octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, SEP, 0x hex digit SEP, 0x hex digit SEP, hex digits, SEP, hex digit SEP, hex digit, plus SEP, hex digits, plus SEP, numeric literal separator hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal, integer literal, non-octal decimal, integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note to non-strict code. This syntax is legacy. 2, 9, 3, 2 static semantics. MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in
If it goes from the vertex shader to the fragment shader,
integer literal exponent part is the MV
why is there an in?
is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal. Non-zero digit numeric literal separator of decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal digits. Decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer, decimal digits, is the negative of the MV of decimal digits. The MV of decimal digit, 0 or of hex digit, 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error in not the 2 input elements 3 and in legacy octal escape sequence. 0 or of binary digit. 0 is 0, the envy of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the envy of decimal digit. 2 or of non-zero digit, the envy of decimal digit. 3 or of non-zero digit, the envy of decimal digit. 4 or of non-zero digit, the envy of decimal digit. 5 or of non-zero digit, the envy of decimal digit. 6 or of non-zero digit, the envy of decimal digit. 7 or of non-zero digit, the envy of decimal digit. 8 or of non-zero digit, the envy of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the envy of hex digit, or of hex digit. A is 10, the envy of hex digit. B or of hex digit. B is 11, the envy of hex digit. C or of hex digit. C is 12, the envy of hex digit. D or of hex digit. D is 13, the envy of hex digit. E or of hex digit. E is 14, the envy of hex digit. F or of hex digit. F is 15, the envy of binary digits. Binary digits. Binary digit is the envy of binary digits 2 plus the envy of binary digit. The envy of binary digits. Binary digits numeric literal separator binary digit is the envy of binary digits plus the envy of binary digit. The envy of octal digits. Octal digits. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of octal digits. Octal digits numeric literal separator octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of legacy octal integer literal. Legacy octal integer literal octal digit is the envy of legacy octal integer literal times 8 plus the envy of octal digit. The envy of non-octal decimal integer literal. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L, non-octal digit is the envy of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D
Alright, this is the vertex file.
A L. Capital I N T E.
That's why ones use them.
Times 10 plus the envy of non-octal digit. The envy of non-octal decimal integer literal. Non-octal decimal integer literal decimal.
This one's really color or something.
Decimal integer literal times 10 plus the envy of decimal digit. The envy of capital L E G A C.
Out means out means going to the fragment shader.
Capital L I
So one out frag UV. I'll make my own.
M A.
Give it a name.
Capital I N T E G E R. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L. Octal digit is the envy of capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L times 10 plus the envy of octal digit. The envy of hex digits. Hex digits. Hex digit is the envy of hex digits 16 plus the envy of hex digit. The envy of hex digits. Hex digits numeric literal separator hex digit is the envy of hex digit 16 plus the envy of hex digit 2 9 3 3 static semantics. Numeric value. The syntax directed operation numeric value takes no arguments and returns a number or big int. It is defined piecewise over the following productions. Numeric literal, decimal literal, return round.
So frag UV is 2.
Numeric literal, non-decimal integer literal, return, envy of non-decimal integer literal. Numeric literal, legacy octal integer literal, return, envy of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix.
Being assigned.
Of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal. Non-zero digit big int literal suffix 1. Return a big int value for the envy of non-zero digit. Decimal big integer literal. Non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the envy of non-zero digit 10n plus the envy of decimal digits. Return z. Envy 2, 9, 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U+005C, reverse solidus, U+000D, carriage return, and U+000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate TCMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as
Alright, so try to do this.
1. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2.
I'll send yellow.
Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation,
It's vector 4.
character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence, 30, ECMA International 2024, escape sequence, character escape sequence,
Vector 4. Same name.
escape sequence, hex escape,
That one's gonna be in.
character escape sequence,
Copy paste.
escape character, single escape character,
Like, this is so boring.
character, source
I'm so bored.
character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence,
It's what I already have here, so it's good.
9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit,
So right now, out color is red.
octal digit but not 0, 0 to 3, 1 of 0, 1, 2, 3, 4 to
Where it should be.
1567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1, 2, 9, 3. Source character is defined in 11.1, ECMA International 2024 231. Note 2, LF. MCR cannot appear in a string literal, except as part
Can only one thing be at a location at a time?
A way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2 9 4 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text match by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2 9 4 to static semantics, SV. The syntax directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various
I'm gonna set out color equal to
some Unicode code points within the string
GC, whatever this is.
or in 1, 2, 9.
Should be all.
Literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character.
Hooray, it's yellow. So exciting.
Performing UTF-16 encode code point on the code point matched by source character. The SV
Alright, I figured that out.
string value
How the fuck do I get an image on there?
8. Line separator. The SV of double string character, PS, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character. Line continuation is the empty string. The SV of single string character. Source character but not one of or line type.
Our image is applied to the vertex.
Encode code point on the code point matched by source character. The SV of single
Shooter.
is the string value consisting of the code unit 0 times 2028. Line separator. The SV of single string character, PS, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single
This is not directly. That's cool.
string. The SV of escape sequence. 0 is the string value consisting of the code unit 0 times 0000. Null. The SV of character escape sequence. Single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note 2, it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7, use strict. 32, copyright sign, ECMA International 2024, table 38. String single character escape sequences, escape sequence, code unit value, Unicode character name, symbol, B, 0 times
So Jeff puts as an example with a textured quad.
09, character.
What I want is my textured quad, not some new bandangled, whatever the word is, spandangled. I don't know.
Form
I don't want a new freaking quad. This quad, it works. So I'm sticking with this quad.
apostrophe,
I'm not gonna start whole new quad adventure
times 005C, reverse.
with Jetbot. For fuck's sake.
Source character but not one of escape character.
So I can give you a new one. Start over. Let's have fun. Like, fuck no.
Sequence. Legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence, the SV of non-octal decimal escape sequence.
I'm gonna say I can change
Unit 0 times 0038, digit 8, the SV of non-octal.
the quad yellow.
String value consisting of the code unit 0 times 0039, digit 9, the SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence, the SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4, 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is, 8 times the MV of 0 to 3 plus the MV of octal digit, the MV of legacy octal escape sequence, 4 to 7 octal digit is, 8 times the MV of 4 to 7 plus the MV of octal digit, the MV of legacy octal escape sequence, 0 to 3 octal digit is, 64, that is, 82, times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus.
Alright, so now as a chatbot, I can change the quad yellow by setting it in the vertex as an out, then to the frag shader as in,
5 is 5.
or then in to the frag shader.
MV of 4 to 7. 7 is
How do I apply
X hex.
an image?
16 times the MV of the first hex digit plus the MV of the second hex digit, the MV of hex 4 digits. Hex digit is 0 times 1000 the
How do I apply an image to my quad? Not a new quad. My quad.
hex digit plus the MV of the fourth hex digit. ECMA International 2024 233. 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input.
Yes, that's correct. I want to keep my existing quad. I don't want to make a new goddamn quad. That's not fun. I'm not going on a quad adventure with chatbot. That was like 5-6 hours. I'm not doing that again.
Find in 2 2 2 1.
I want to apply it to my quad, existing quad.
Find below all the production.
I'm not making a new quad. Like chatbot said right there.
Body regular expression flags. Regular expression body.
No chatbot saying this, but it's gonna be like, you want to start a new quad? Like, fuck no.
Expression char. Regular expression.
I'm gonna say no every single time.
But not one of all.
I'm not gonna fall for it again.
E U L A R capital E X P R E S S I O N capital B A C K S L A S
It said,
E Q U regular expression class. Regular
while also understanding how to combine vertex color and texture sampling.
U
I don't care to understand.
capital
I just need this program done.
E S S
And chatbot can't do it for me, so I gotta do it.
C K S
Really annoying.
S H capital S E Q U regular expression class. Capital R
How to apply an image to textured quad.
A R capital E X P R E S S I O N capital B A C K S L A S H capital S E Q.
Your vertex shader must output texture coordinates
Source character but not line
from its vertex, input, or hard-coded attribute.
expression class.
Fragment shader must sample your texture using frag-uv.
Regular expression.
Oh, this is so boring.
Capital R E G U L A R capital E X P R E S S I O N capital B A C K S L A S H capital S E Q U. Note 1 a regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in the program evaluate to regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. C22, 2, 4, 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char. 2, 9, 5, 1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions. Regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1 2 9 5 to static semantics. flag text. The syntax-directed operation flag text T takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax: template, no substitution template. Template head, no substitution template. Template character sop, template head. Template character sop, $, template substitution tail. Template middle, template tail, template middle. Template character sop, $, template tail. Template character sop, template characters. Template character, template character sop. Note: 2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use .dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or.
Alright, I want a fucking image, chatbot. I want a damn image.
Escape sequence Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead.
I need an image. Stop saying UV.
Digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead. Not code point. Hex digits. Sep. But only a family of hex digits. 0 times 10 FF. Code point. Hex digits. Sep. But only a family of hex digits. 0 times 10 FF. Note: template substitution tail is used by the input element. Template tail alternative lexical goal 1, 2, 9, 6. 1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail.
How long could it take to make an image?
Template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code. The point matched by source character. The TV of template character, $, is the string.
It took that long to generate that.
$, the TV of template character.
Oh my god.
The SV of template escape sequence. The TV of template character, not escape sequence is undefined. The TV of template character, line terminator sequences. The TRV of line terminator sequence, 236. Copyright sign, ECMA International 2024. The TV of line continuation, line terminator sequences. The empty string 1, 2, 9, 6. To static semantics, TRV. The syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to of a template object.
I want to make the outline of an animal or something, like a squirrel.
Sequences are interpreted as they appear in the literal, the TRV of no substitution template.
Because I could just cheat and say that it's an image, but then UV it.
$, is the empty string.
Which I could totally see it doing. I'd be like, oh, I did a UV. It looks like the image, doesn't it?
Characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $, is the string value consisting of the code unit 0 times 0024. $, the TRV of template character, template escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence. The TRV of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence. The TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0. The TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit. The TRV of not escape.
What?
Look ahead hex digit is the.
That made me reach my limit. Was that one fucking image?
Small letter X. The
Wow.
X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter X, and the TRV of hex digit. The TRV of not escape sequence, U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter U. The TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex digit. The digit hex digit, look ahead hex digit, is the.
Well, I think I'm done for now.
075, Latin.
I don't want to open a new tab.
the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence, U hex digit.
And this is getting really old.
The head hex digit is the string concatenation of the code unit 0 times 0075, Latin small letter U.
Alright, so tomorrow
The
I'm gonna have to actually like learn something,
digit,
which I don't want to do because I don't care. I really don't care.
string concatenation
I just want chatbot to just do it for me.
code unit 0
That's not fucking possible.
bracket,
So I have to do it then.
U, not code point, look,
Which pisses me off.
of the code unit 0,
I thought I'd be able to sit here and like lazily have chatbot do it for me,
left curly bracket,
but it just keeps getting more and more and more complicated.
U, code point, look ahead hex digit, look ahead,
So I'm gonna have to figure it out tomorrow.
0 times 0075, Latin small,
Freaking AI my ass.
left curly bracket, and the
So dumb.
decimal.
It's not AI.
1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character, wannabe FNRTV, is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence. X hex digit is the string concatenation.
Chatbot can't even convert
Small letter X. The
bit shifts to the number that they are.
The TRV of Unicode escape sequence. U hex 4 digits is the string concatenation of the code units 0 times 0075, Latin small letter U, and the TRV of hex 4 digits.
Like, I do not understand how chatbot could not work. This is like fundamentally broken.
The code unit 0 times 007B, left curly bracket, the TRV of ECMA International 2024-237, code point, and the code unit 0 times 007D, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the
So, I don't know.
hex digit is the string concatenation
I'll pick up on this tomorrow.
of hex digit.
I got the stupid.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCD.
I made no progress today.
16 encode code point on the single code point matched by this production. The TRV of line continuation, line terminator sequence is the string concatenation of the code.
I need to not rely on chatbot. I need to like actually think about what I'm doing
Data sequence, LF,
and make a decision.
listing of the code unit 0 times 0, 0,
So I figured out how like
value consisting of the
to pass a fucking color from one thing to the next thing.
LS is the string value.
All I gotta do is figure out how to get an image onto the plane.
PS is the string
It shouldn't be that complicated. I mean, you could change the color like that.
CRLF is the string value consisting of the code units 0 times 000 line feed 2.10 automatic semicolon insertion. Most ECMA script statements and declarations must be
You go up here, you can set it to in or out,
for convenience. However,
and then this file takes in from the other file.
these situations are described by saying that semicolon
I can make another variable called Bob Potato.
2, 1, 0, 1 rules of automatic
Give it like 3,
token means the actual recognized lexical token determined using the current lexical.
called Potato.
There are 3 basic rules of semicolon insertion. When, as the source text is passed from
So this file takes in this keyword potato at location 3.
be inserted before the offending token if one or more of the following conditions is true. The
And this file goes out
token by at least one line terminator. The
at location 3. Just out.
passed as the terminator.
Try potato. So now I set potato here.
2. When, as the source
It's the color brown.
right. The end of the input stream of tokens is if
Because potatoes are brown.
pass the input token stream as a single instance of the goal.
Unless they're like bleached, then they're like white. I don't even know.
The source text is passed from left to right. A token is encountered that is allowed by some production of the grammar, that the production is a restricted production and the token would be the first token for a terminal or non
Set to vector 4.
no line terminator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted
We'll make brown.
token by at least one line terminator, then a semicolon is automatically inserted before the restricted token.
Maybe like
Line continuation while TRV includes them, CR, LF, and
60% red.
LF, for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF, sequence 38, ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted.
30% yellow.
Semicolon would then be passed as an empty statement, or if that semicolon would become one of the 2 semicolons in the header of a for statement C14, 7, 4, not, either following are the only restricted productions in the grammar. Update expression, yield.
20% blue.
side expression yield await. No line terminator here. Plus plus left hand side expression yield await. No line terminator here. Continue statement. Yield await. Continue. Continue. No line terminator here. Label identifier yield await. Break statement. Yield await. Break. Break. No line terminator here. Label identifier yield await. Return statement.
Maybe
Return. No line terminator here. Expression.
50% blue, 70% red.
Row. No line terminator here. Expression. Plus in yield await. Yield expression. In await. Yield. Yield. No line terminator here. Assignment expression in. Plus yield await. Yield. No line terminator here.
I have no idea. See if this is brown.
Arrow function. In. Yield. Await. Arrow parameters yield await. No line terminator here.
So this file will send out
Operation. Yield. Await. Default.
to this file.
Terminator here. Function binding.
It's in the pipeline, whatever.
Yield. Plus.
How's that equal to like a potato?
Sync. No line terminator here. Function. Formal parameters. Yield. Plus await. Async function body.
Oh, that's why this is binding to 0.
Line terminator here. Function binding identifier.
Because 0 goes to the program, the C program.
Async function body.
I think I got it.
Await.
So that's how that works.
Here. Class L.
So I just gotta figure out how to pass in. Okay, I think I got it figured out.
Async generator declaration.
So it has to be bound to 0. Or I could pick a different one, I think.
Function.
But default to 0.
Formal parameters.
I pass in
Async generator body. Plus.
the image in the 0th.
Formal parameters. Plus yield.
I think the name has to match up from the C program or something.
To here. Function binding identifier. Plus yield. Plus await opt. Formal parameters. Plus yield. Plus await.
But then it's also passing in on the stack when you push them in or something. So I don't know if I go tomorrow. I'm gonna see if this is brown.
Yield. Plus await. Async generator body. Async arrow function. In. Yield. Await. Async. No line terminator here. Async arrow binding identifier.
That's nowhere close to brown.
Equals. Async concise body in. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y.
Well, 25, 25,
R R. Yield await.
50.
To here equals async concise body in ECMA International 2024 239. Async arrowhead. Async. No line terminator here. Arrow formal parameters. Yield.
Or 50, 50, 20, 30.
As follows. When a plus plus or
See if that's brown.
where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a
It's like a pink sock. Pink. Where the hell's the mouse?
throw or yield talk, and is encountered and a line terminator is encountered before the next token. A semicolon is automatically inserted after the continue, break, return, throw, or yield token when arrow function parameter
Man, everything is pink.
before it equals token.
I guess I need a lot less red.
The punctuator causes a syntax error.
Or a lot more blue and green.
Token. A semicolon is automatically inserted and the async token is not treated.
Like 70
Class element is the following tokens. One listen
or 16, 80.
token. A semicolon is automatically inserted.
This might be more purple.
Syntax error. The resulting practical advice to ECMA script programmers is a postfix plus plus or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield. Expression should start on the same line as the
I guess that's white.
token. A label identifier in a break or continue statement.
Wait, why is the background brown?
The end of an arrow function's parameter, S, and its equals, should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2, 1, 0. 2 examples of automatic semicolon insertion. This section is non-normative. The source, 12, 3, is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source, 1, 2, 3, is also not a valid ECMA script sentence. It is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMA script sentence. The source, 4A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, a plus B, is
That's closer.
colon insertion into the following. Return, a plus B. The source, up equals B plus plus C, is transformed by automatic semicolon insertion into the following. Up equals B, plus plus C. The source, if B, else C equals D, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement. The source, up equals B plus C, D plus C print, is not transformed by automatic semicolon insertion because the parenthesized expression
That's not closer.
interpreted interpreted as an argument list for a function call equals b plus c, d plus c print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than
Oh, there's purple.
insertion 2, 1, 0. 3 interesting cases of automatic semicolon.
Man, my color game is off.
The expression a plus b is not treated as a value to be returned by the return statement because a line terminator separates it from the token return. Note 2, the token plus plus is not treated as a postfix operator applying to the variable b because a line terminator occurs between b and plus plus. ECMA International 2024-241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line.
Alright, it's almost brown.
It's a cross-line terminator.
No, that's close enough to brown.
ECMA script. Additional grammar productions.
I'm tired of this. It's getting old.
Semicolon insertion preceding them to change grammar productions when parsed.
I'll figure out how to get the desktop on this spinning. Well, I did get it spinning today, and I got it to the ratio, so I had to get something done, I guess.
In cases of automatic semicolon insertion.
I just planned to have the whole thing done.
1, 0, 3, 1 intro.
It didn't go that way.
In statement lists. In a statement list, many statement list items end in semicolons, which make
So, until next stream, I'm gonna let the stream run on for 10 more minutes because it doesn't always send the whole stream. So if I like go on for 10 more minutes, it might send the whole stream.
the two
Maybe it won't. Maybe it will. Modern software is crap.
lines together.
Old school software is also crap.
Template literal. Without a semicolon, the two
There's like crap all around us.
of March 2011, with the previous expression as the member
I don't know. Anyways, peace.
semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3, 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here. In this version of ECMA script, 2, 1, 0, 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2, 42, ECMA International 2024, 13 ECMA script language, expressions, 3.1 identifier syntax, identifier reference, yield, await, identifier, yield, await, binding identifier, yield, await, identifier, yield, await, label identifier, yield, await, identifier, yield, await, identifier name but not reserved word. 3, 1, 1 static semantics, early errors, binding identifier, it is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval, identifier reference, yield binding identifier, yield label identifier, yield, it is a syntax error if the source text matched by this production is contained in strict mode code, identifier reference, await binding identifier, await label identifier, await, it is a syntax error if the goal symbol of the syntactic grammar is module, binding identifier, yield, await, yield, it is a syntax error if this production has a yield parameter, binding identifier, yield, await, ECMA International 2024-243, yield and await are permitted as binding identifier in the grammar, and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter, identifier reference, yield, await, identifier binding identifier, yield, await, identifier label identifier, yield, await, identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3, 1, 2 static semantics, string value. The syntax directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier part. Let id text unescape the identifier code points of identifier name, return code points to string, id text unescaped, identifier reference, yield binding identifier, yield label identifier, yield, return yield, identifier reference, await binding identifier, await label identifier, await, return await, identifier name but not reserved word, return the string value of identifier name, private identifier name, return the string concatenation of 0 times 0023, number sign, and the string value of identifier name, module export name, string literal 1, return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024. 131. 3 Runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression. Yield. Await. This. Identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Expression plus and yield await. Expression plus and yield await. Dot. Binding identifier yield await. Dot. Binding pattern yield await. Expression plus and yield await. Binding identifier yield await. Expression plus and yield await. Binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024-245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await. The interpretation of capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, is refined using the following grammar. Parenthesized expression, yield, await, expression, plus and yield await. 3, 2, 1, at this keyword. 3, 2, 1, 1 runtime semantics, evaluation, primary expression, this, return. Resolve this binding. 3, 2, 2 identifier reference. C13.1 for identifier reference 1, 3, 2, 3 literals. Syntax, literal, null literal, boolean literal, numeric literal, string literal. 3, 2, 3, 1 runtime semantics, evaluation, literal, null literal 1. Return null, literal, boolean literal. If boolean literal is the token false, return false. If boolean literal is the token true, return true. Literal, numeric literal. Return the numeric value of numeric literal as defined in 1, 2, 9, 3. Literal, string literal. Return the SV of string literal as defined in 1, 2, 9, 4, 2, 46. ECMA International 2024. 1, 3, 2, 4 array initializer. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax, array literal, yield, await, elision ort, element list yield await, element list yield await, elision ort, element list, yield, await, elision ort assignment expression, plus and yield await, elision ort spread element yield await, element list yield await, elision ort assignment expression, plus and yield await, element list yield await, elision ort spread element yield await, elision, spread element, yield, await, dot, assignment expression, plus and yield await, 1, 3, 2, 4, 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision, let len be next index plus 1. Perform. Set, array, length, len, true. Note, the above step throws if len exceeds 232 1. Return len, elision, return. Array accumulation of elision with arguments array and next index plus 1. Element list, elision ort assignment expression. If elision is present, then as set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value, init result. Perform. Create data property or throw, array, to string, next int x, init value. Return next index plus 1. Note an array literal is an expression describing the initialization of an array, using a list of 0 or more expressions each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024-247. Element list. Elision spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x init value. Return next index plus 1. Element list. Elision spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return next index. C perform. Create data property or throw array to string next int x next d set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2 runtime semantics. Evaluation array literal elision let array be. Array create 0 if elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array literal element list let array be. Array create 0 perform. Array accumulation of element list with arguments array and 0. Return array literal element list elision 2. Let array be. Array create 0 let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array 3, 2, 5 object initializer. Syntax object literal yield await property definition list yield await property definition list yield await property definition list yield await property definition yield await property definition list yield await property definition yield await property definition yield await identifier reference yield await cover initialized name yield await property name yield await assignment expression plus and yield await method definition yield await dot assignment expression plus and yield await property name yield await literal property name computed property name yield await literal property name identifier name string literal numeric literal computed property name yield await assignment expression plus and yield await cover initialized name yield await identifier reference yield await initializer plus and yield await initializer in yield await assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign, ECMA International 2024-249. Note 3 in certain contexts. Object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5. 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N or capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proturned at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions: property name, literal property name, return false, property name, computed property name, return true. Addition to describing an actual object initializing the object literal productions are also